The ocean covers almost 3/4 of the planet. It's difficult to overstate the importance of the ocean for our life on this planet. Every second breath we take comes from the ocean. It's the source of much of our food and of our water. We travel and trade upon it, brings us joy and economic benefits in the shape of the world's tourism industry. It is clear that appropriate management of the ocean resources will be the key to reducing poverty and to achieving the Sustainable Development Goals.
Good morning, ladies and gentlemen. Welcome to the 2022 Ocean Roundtable Dialogue of PEMC, focusing on the East Asian Sea's response to the global climate change challenge. My name is Daisy Padayaw, Program Manager at the PEMC Resource Facility, and I will be your virtual host for today. This June 8, we celebrate the World Ocean Day as we dive deep into the links between our ocean and climate in the East Asian Seas region from 9 a.m. to 3 p.m. Manila time with a 1-hour lunch break. We will be joined by senior climate change experts from PEMC's country and non-country partners and other organizations from the region who will demonstrate how ocean-based adaptation solutions are incorporated in national adaptation plans and nationally determined contributions, as well as the respective country and the region's progress and best practices in utilizing tools and management systems to mitigate risk and enhance coastal resilience. The results of today's discussion will help shape the development of the 2023 to 2027 implementation plan of the Sustainable Development Strategy for the Seas of East Asia, the preparation of which started last year during the East Asian Seas Congress 2021. We expect to have this regional plan approved at the 14th East Asian Seas Partnership Council meeting in November this year. I can see that we have quite a number of participants here in Zoom, coming from about 27 countries across the globe. And this does not yet include those joining us via live stream in Facebook. To be able to monitor today's attendees and provide the certificates of participation, kindly fill out the attendance sheet provided in the chat box. Participants may submit questions for the speakers through the Q&A box in Zoom. We'll also be entertaining questions from those joining us via live stream. When asking, do share your name, affiliation, and location, and address your questions to a specific speaker if possible. To formally open this webinar, we are pleased to have with us Mr. Arif Yuano, the Chair of the East Asian Seas Partnership Council and concurrent Senior Advisor on Foreign Cooperation, the Minister of Environment and Forestry of Indonesia. Pa Arif is no stranger to climate change discussions. He has been active in climate change and other international negotiations and discussions in various capacities for Indonesia over the past 10 years. And currently, he is working also on a nature-based solutions project with World Bank. Ladies and gentlemen, please welcome Mr. Arif Yuano.
Thank you, Jesse. Good morning, distinguished guests, ladies and gentlemen. Welcome to the 6th East Asian Seas Ocean Roundtable Dialogue. Since 27, PEMC has been facilitating and catalyzing effective dialogue on key issues, including fisheries, health, marine pollution, ocean-based industry, and trade. And today, on the climate change as they relate to the future of the region, ocean, and coast. We frame the dialogue around the blue economy development, where there are clearly huge restoration challenges, but also a sizable blue economy opportunity. We do this using the Sustainable Development Strategy for the Seas of East Asia, or SGSC, which serve as a foundational framework for guiding and driving blue economic development in the region. We are all aware of the indispensable role that the ocean plays in providing and regulating resources that are vital to sustaining life on Earth, from rainwater to drinking water and as a source of our food, weather, and the oxygen we breathe. More than 3 billion people rely on the ocean for their livelihood, most of them in developing countries, like many of the PEMC country partners. With water temperatures and sea level rising, acidification, pollution, unsustainable exploitation of marine resources, depletion of fish stock, and the near disappearance of coral reef, and destruction of fragile ecosystem. The ocean is being disproportionately impacted by human activities. The ocean is an important life support system for the planet and is a vital resource for fighting climate change. It is critical that we protect, manage, and restore coastal and marine biodiversity. Recognizing the key role that the ocean plays for people all over the world, the United Nations, of which our country or member states have adopted a sustainable development goals focused on conserving the ocean with target for action on an array of problems. While some progress has been made, more is needed to secure our ocean future. The role of the ocean and the coastal and marine ecosystem in climate change mitigation is often overlooked. Protecting and restoring ocean habitats such as seagrass beds, salt marshes, mangrove, and their associated food webs can sequester carbon dioxide from the atmosphere at a rate up to 5 times greater than tropical forests. Choosing not to prioritize the protection of our ocean is depriving us of the tools that we desperately need to achieve our climate adaptation and mitigation goals. Today, we will hear from our country partners and experts on what action and solution they are taking to honor their commitment at the global, regional, and national levels. This ocean and climate dialogue is our region version of country coming together as one with a global meeting, such as the United Nations Ocean Conference, which is scheduled to take place in Lisbon, Portugal, from June 27 to July 1st. This roundtable dialogue offers an opportunity for country and relevant stakeholders to come together and join our world leaders to present the action and solution that our ocean desperately needs. The ocean knows no boundaries. It unites us all as a physical link between coastal countries, communities, and individuals, and as the source of our food, water, and air. We all face similar challenges and similar opportunity. As a member of the Partnership in Environmental Management for the Seas of East Asia, or PEMC for short, let us join the rest of the world in being bold for the ocean together. Thank you very much.
Thank you very much, Pa Arif. Your remarks set the perfect tone to start the roundtable dialogue. To provide further context to the event, we have with us one of PEMC's non-country partners, the Korea Institute of Ocean Science and Technology, or KIOST, to expound on the links between ocean and climate change and discuss how ocean-related issues and solutions became an important part of the global climate change discussions. Ladies and gentlemen, please welcome Dr. Hyun Woo Kang, Director of the Ocean Climate Prediction Center of KIOST. Dr. Kang?
Well, thank you, Daisy. Good morning, everyone.
Dr. Kang?
Yeah, first of all, I'd like to open my screen first. Okay. All right, now you can see my slide. Is that right?
Yes, Dr. Kang, it's
Okay.
clear.
Yeah, thank you very much. Just I'll change my point options simply. Yeah, good morning again. It's my great honor to have this opportunity in front of such distinguished representatives from various countries in East Asia. Today, I'm going to introduce the state and the trends of ocean in connection with the Earth's climate change. I hope my talk reminds you once again that thanks to the ocean, we can live, and the ocean is endangered. Thus, we need to do something to protect it. Before moving forward, I propose to use ocean climate is a kind of a compound noun rather than the two separate words. As we know, the weather or climate is very different. The Wikipedia defines the climate as kind of a long-term weather pattern in an area, typically average over 30 years. In a broader sense, climate is defined as a kind of the state of components of the climate system, including the atmosphere and the hydrosphere, cryosphere, the lithosphere, and as well as the biosphere. And the most important thing is that the interactions between or among them. So the main concept of climate is the long-term mean state of the Earth's system components and their interactions. As we know, the two components we should focus in ocean are the marine environments and marine ecosystems. So therefore, ocean climate is the kind of a long-term average state of marine environments and ecosystems, including the interactions with other components of the Earth's climate system. This is the terminology that the Ocean Climate Prediction Center and KIOST are using. So my talk is prepared like this. To begin with, I introduced the recent changes and the future projections of ocean climate based on the IPCC sixth assessment report, AR6, which is released last year, especially for the physical science part. And we could come across again, the ocean is at risk through this review. And some of the international endeavors introduced, such as Glasgow Climate Pact and Sustainable Development Goals, etc. I close my talk with a short introduction to the KIOST research activities on the ocean climate change. These are the key components on changes of oceans. And the ocean climate shows some kind of a lot of components, and also it has some kind of the change or the state or trends. Physically, as you know, the ocean consists of liquids and solid forms of water and the basins enclosed by the lands. The seawater and the sea ice are interacting with each other in the polar regions, as we know, the Arctic region and as well as the Antarctic. And the atmosphere exchanged the water, heat, and carbon dioxide with oceans at the interface between them. The consequences of global warming or climate change are increase of ocean heat content and decrease of the sea ice or land ice as well. And also it makes some kind of an increase of the marine heat waves as well as sea level rise. So all these kind of things happen through the ocean current. Ocean current change due to the changes of ocean temperature, salinity, and as well as wind patterns. The energy and materials inside the ocean are redistributed as a result of this. This is the changes of marine environment, I guess. And chemical changes of ocean due to warming, decreased ocean pH, and dissolved oxygen concentrations, which changes also the marine ecosystems in the end. Physical components of the ocean is a key driver of the Earth's climate because the liquid water heavier than air powerful and the oceanic currents are slower compared to winds. And all the changes stored in the ocean persist longer than the atmosphere and the lands. This is why we can say the ocean is the climate regulator of the Earth. Here's some examples of the global energy stored in the ocean and the consequences of the sea level change. The graph shows that the energy change in jettajoules, jetta means about 10 to the 21, which means that we have 21 zeros after the one, the huge amount of the energy stored in the ocean, and the portion of the ocean's energy is increasing. It takes about more than 90% of total energy at the moment. The energy stored in the ocean, upper ocean, approximately up to 2,000 meters. And these energy stored in the ocean inflate the volume of the seawater and resulting in sea level change and actually sea level rise, which is about 40% of the sea level of total change. And mass input from melting ices such as glaciers or Greenland and Antarctica ice sheet melting is another big source of the sea level rise as well. Historically, the sea surface temperature have risen about 0.88 centigrades during the last 120 years, while, as you know, the 1.09 Celsius have risen for global surface mean surface temperature. To our surprise, more than 70% of this change happened during the last 40 years since 1980. And also the future projections tell us that the 0.86 to 2.89 centigrade rise depending on the greenhouse gas emission scenarios. The simplest, the lower emission scenarios, SSP1, that's 2.6, which whose net zero means about 2080, also increase of 0.86 rate. And scientists use more than 40 climate or system models for these future projections. The right pane shows that kind of the model performances. We don't know all these kind of complex figures, but I would like to say that each model has its own strengths and weaknesses depending on its component models and couplers working. It is interesting or ironical that the ensemble prediction, or simply the average of many model results, is better than each one. This is why we use many models as possible to predict future precisely. Ocean circulation change can be simply summarized like this. The upper pane shows some kinds of the volume transport, which means that how many waters passing through the ocean, and the lower panel shows that the speed of the ocean current. We know the Croatia in the Western Pacific and the Gulf Stream in the Atlantic Oceans. The warming itself triggers some kinds of wind stress change, and it also changed the ocean current. And these are too strong. They are actually too strong western boundary currents, as I mentioned before, the Croatia and the Gulf Stream. And the right pane shows that these two oceanic currents behave differently. It is interesting that the water volume transports of both currents have been decreased like this, but the current speed, the Croatia current speed is increased while the Gulf Stream decreased. We still don't know the reason yet. Historical global mean sea level changes shown about 20 centimeter increase during 1901 to 2018. And after then, we can predict or project the greenhouse gas scenario-based projections like this from depending on the scenarios. And it shows that the SSP1 scenarios, which has some kind of net zero achieved around 2050, still has about 40 centimeter increase of the sea level, and the SSP5 8.5 shows that about 77 centimeters in 2100. The crucial point to remember that the rising rate is not linear, as sea level rise faster as time goes by. Excess energy is stored in the upper ocean, sea surface temperature is going up, and the ocean current patterns are changing, sea level is rising and accelerating. This is not just instantaneous state change, which can be resilient, but their mean state change, at least average longer than the 30 years, which means the ocean climate is changing, which might not be recoverable. The companion events or phenomena are also changing. The marine heat waves increasing, and dissolved oxygen gas is decreasing. We call this is the deoxygenation, and the ocean acidification, which means that the pH is decreasing as well. And Atlantic meridional obtaining circulation, AMOC, is also decreasing. This is the kind of a vital sign of the ocean conveyor belt. It foretells a tipping point of the Earth's climate is coming. The occurrence and intensity, duration of marine heat waves are increasing as well. If this happened in coastal area, especially in aquafarm regions, a lot of fishes could not survive. Until now, regional differences are shown, but the future scenario shows us that there might be no exceptions or area differences. As I told you before, that the direct observations during the last 40 years show that almost all the region of ocean shows this kind of ocean acidification. And also the ocean oxygen, dissolved oxygen is depleted or decreased. The blue color shows there are many oxygen minimum zones in the world ocean, and this is expanding. And red dots show where the oxygen is almost depleted sometimes in a year, so-called dead zone, so highly distributed in the coastal area of almost all the continents. where life below ocean is not sustainable if these kind of things happen persistently. Hypoxia or dead zone is not only because the ocean warming or stratification of water column, it is highly connected to the marine environment change, interacting with land use and human activities as well. It's kind of the cultural eutrophication. It is believed that the ocean produces about 50% atmospheric oxygen, but we lost about 2% during last 50 years. The simplest conclusion is that the ocean climate, the mean state of marine environment and marine ecosystem matters, but endangered. To save our ocean or our planet, the United Nations established 17 Sustainable Development Goals in 2015. So we know the goal 13, the climate action, to take urgent action to combat climate change and its impacts. And the goal 14 is about life below water, to conserve and sustainable use the ocean, seas, and marine resources as well. Careful management of these essential global resources is a key feature of a sustainable future preserving a habitable planet. These kind of things is finally recognized by the Glasgow Climate Pact outcome of this COP26 last year. The marine ecosystems act as sinks and reservoirs of greenhouse gases, and we know the biodiversity of them should be protected. It is essential to hold ocean and climate change dialogue to strengthen ocean-based action, and today's round table is for that kinds of purpose. And also UN designated Decade of Ocean Science for Sustainable Development from 2021 to 2030. It is very interesting that it is not the decade of ocean, it is the decade of ocean science. The ocean science we need is to make the ocean to perform its function as usual. We need to understand the roles and functions of ocean for our planet. There are 10 decadal challenges and 7 ocean we want, or 7 decadal outcomes: a clean, healthy, productive, and predictive, and also safe oceans, accessible and inspiring oceans. All these kind of purposes highly related with the PEMC, I guess. For the efforts of the scientific purpose, a collaborative research program proposed in connection with Ocean Decade. It is called the Second Cooperative Study on the Crucial and Adjacent Regions. And actually the first CSK program conducted during the 1965 to 1979, about 50 years ago. Now we would like to revisit this area again and to measure how the ocean climate state is changing. Many studies related with marine environment and ecosystems around the crucial region has been started in preparation by adjacent countries like this. Studies on ocean climate change in Kyoto use the 3 major research infra, the Global Ocean Color Imager GOSI, sensors mounted on geostationary satellite, and also the research vessels of such as ISABU and the Kyoto Earth System model like this. And we are involving this kind of research or investigating activities such as the ocean typhoon interactions and marine heat wave predictions. And also it is related with some the carbon capture and utilization storage program. And the Ocean Climate Prediction Center, where I'm involved, in Kyoto, it is just established last year, and the fundamental mission of the OCPC is to examine and predict the ocean climate periodically, producing the monthly ocean climate review and the seasonal climate outlook, doing ocean climate literacy promotion, and functioning as an ocean climate nexus. Currently, our main area is about 47 to 50 of large marine ecosystems, and will expand gradually to PEMC region by 2025. I will conclude with the following message. Ocean-based solution for climate change is very important. For this, International collaborations are not an option, but indispensable. Thank you very much.
Thank you, Dr. Kang, for expounding on the impacts of climate change to our oceans, such as deoxygenation or hypoxia, ocean acidification, marine heat waves, among others, and how these are being addressed in various international commitments, such as the Glasgow Climate Pact, the UN SDGs, the UN Decade for Ocean Science for Sustainable Development, as well as the various ocean and climate researches of KIOSTs. Dr. Kang's presentation sets the context for linking scientific researches to better inform national policies, plans, and ocean-based adaptation measures in response to climate change. We now begin with the first part of our program, focusing on the integration of ocean-based adaptation solutions and blue carbon initiatives into national development plans and policies, particularly the National Adaptation Plans, or NAPs, and the Nationally Determined Contributions, or NDCs, and their respective implementation. We have with us presenters from Cambodia, China, Japan, Lao PDR, Philippines, RO Korea, Singapore, and Vietnam. Each presenter will have 10 minutes for their respective country presentations. First off is Cambodia. We are pleased to have with us Ms. Klok Vichit Ratha, the Deputy Director of the Department of Climate Change of the General Directorate of Policy and Strategy of the Ministry of Environment, Cambodia. Deputy Director Klok, the floor is yours.
Thank you very much for this important event. So I would apologize for some internet may be a little bit slow from here. However, I will try. So today is my pleasure to share with you the. So yeah, and as you may know that the Royal Government of Cambodia recognize climate change as a major challenge to our effort for sustainable development, and the government committed to combat climate change and accelerating to transition to climate resilient, low carbon sustainable mode of development. And also we respond to the climate change is our imperative for the Cambodia, and cannot be separated from the country economic development and poverty alleviation. So the Royal made significant progress in climate change strategy and policy, and is now rolling out our climate change response. In particular, we explicit effort has been made in mainstreaming climate change into national and subnational planning and also budgeting. So yeah. So my presentation will cover the 5-point country information, Cambodian climate change challenge, vulnerable coastal zone to climate change strategy plan 2014-2023, and adaptation solution for the NDC. So this is Cambodian with the total area of 181,035 square kilometer, and population is about 15 million. And we have grown recovery to estimate of 3.1% in 2021. Because our government has implemented policy to mitigate and the negative impacts of the COVID-19 on the business and people income, and to support the economy recovery. And government also focus on the widespread of vaccinate against the COVID-19, which has enabled country to reopen its border, trade and tourists, and leading to the positive economic prospects for this year and the following year. And we have Cambodian have 4 province, coastal province. We call Previ here, Sihanouk, Koh Tong, and Kep, and Kampot. Yeah. So Cambodian recognize climate change as a challenge to the Cambodian effort for development sustainability, even though we have emission only less than 0.1% global GHG emission. However, Cambodian have high vulnerability impacts in terms of severe flood, storm, drought, increasing temperature, sea level rise, changing rainfall pattern, as well as the challenging with the low adaptive capacity and high vulnerability to the economy. And this picture show about the vulnerability of our coastal zone to the climate change, especially according to the 2019 index. We saw the composite of the vulnerability along the coastal zone. And our second national communication have identified that the coastal zone contain diverse and biological important range of natural habitat, including river, forest, mangrove, estuary, beach, and coastal reef. However, the rising sea level will potentially impact coastal system in a number of ways, such as including inundation, flood and storm damage, loss of wetland, erosion, saltwater intrusion, and rising water table. And this will directly and indirectly socio-economic impacts and on the tourism, human settlement, agriculture, freshwater supply, and quality, fishery, financial service, as well as human health in the coastal zone. So this chart shows the vulnerability percentage of the commune in 2014 and 2029 of the 4 coastal provinces. And Cambodian have made a good progress in terms of setting climate change policy and strategies. And the Cambodian Climate Change Strategy Plan 2014 to 2023 is the first comprehensive national policy responding to climate change, with the visioning develop Cambodian toward a greener, climate resilient, equitable, sustainable, and low sustainable and knowledge-based society. And we have 3 goals, with the first goal reducing vulnerability to climate change impacts of critical natural and social system and most vulnerable group. And among these, we have 8 strategic objectives, with objective number 3 focus on the ensure climate resilient and critical ecosystem, which include the Tonle Sap Lake, Mekong River, coastal ecosystem highlight, as well as biodiversity, protected area, and cultural heritage site as well. And related to our NDC, Cambodian have submitted our NDC in 2015 and our update NDC in 2020. 2020, as well as we also in 2021 we have submit our long-term strategy for carbon neutrality as well. And within our NDC updated, we have targeted to reduce emission target to about 40% compared to 2030 BAU scenario. And within our NDC, we have identified 33 priority mitigation action in the sector of energy, waste, industry, transport, agriculture, building, and follow. And we have also 58 priority adaptation action related to the sector of agriculture, coastal zone, energy, human health, industry, and infrastructure. And these are the two adaptation related to the coastal zone within action number 18 and 19 within our NDC update, with action related to protection, risk mitigation, and resilient building from marine population, particularly caused by the activity on the land, including marine population from waste and aquaculture. And the second activity for the coastal zone in the NDC is effective management and protected of ecosystem marine for coastal zone to avoid adverse impact from various factors, build their resilience and restore its function for productive and health ocean. And also under our Climate Change Alliance innovative grant, we also have several projects, as you have seen in this climate activities with the project name and the location and the outcome of the project from CCA3 Innovation Grant. And also we have another regional project we call Building Climate Resilience of Urban Systems through Eco-based Adaptation in the Asia-Pacific region. And this project implement among the four countries, Cambodia, Laos, Myanmar, and Bhutan. And we have identified 14 activities for the Gap province, one of the coastal zone. Here you can see several activities that are implemented under this project. And however, Cambodian have negative impact on our coastal zone, but with the policy institutional arrangement in place, policy in place, we implement several activities. However, we have challenges like limited of financial means to address the adverse impact of climate change, limited of technology transfer, technical expert, and we need to mobilize resource for our implementation of our NDC, as well as we need the participation of involvement from various sectors, youth involvement, and also the consider of the gender for the implementation of the activity. So thank you very much for your kind attention.
Thank you, Deputy Director Cloak, for providing us the perspective on the potential impacts of climate change to the coastal areas of Cambodia, such as sea level rise, saltwater intrusion, drought, among others, and also providing us information on the country's nationally determined contributions, the implementation of the climate strategic plan, some of the country's adaptation measures, as well as ongoing programs. And you also provided us information on the gaps and challenges in addressing the issue of climate change in Cambodia. Thank you once again, Deputy Director Cloak. We move on to our next presenter. Our next presenter is Dr. Lu Wenhai, the Chief of the Division of Marine Ecology of the National Marine Data and Information Service of the Ministry of Natural Resources in China. Dr. Lu, the floor is yours.
Okay. I will share my screen. Okay, good morning, everyone. Glad to share China's progress in the field of blue carbon. In 2020, General Secretary Xi Jinping announced at the 75 United Nations General Assembly that China's carbon dioxide emissions will peak by 2070 and strive to achieve carbon neutrality by 2060. To achieve this, lots of work have been carried out. Today, I will share 5 aspects, including carbon investigations and evaluation, detection, exploration, treating, and basic research. First is investigation and evaluation. China has established an operational marine ecology early warning monitoring system, including typical marine ecosystems, coastal environment, and biodiversity, marine ecological disaster, etc. Since 2019, research on ecological classification and zoning has also been carried out to set the basic framework of monitoring, and the release guidelines are also released. In terms of blue carbon investigation, we have conducted air to see carbon dioxide flux section monitoring, blue carbon ecosystem investigation, blue carbon stock investigation, and pilot monitoring. The air sea carbon dioxide flux section monitoring starts from 2009 and conduct monitoring indicators of the partial pressure of seawater and atmospheric carbon dioxide. Through this monitoring, we can further evaluate the source and sink of carbon dioxide. The blue carbon ecosystem investigation was carried out in 2019 to find out the distribution, area, and ecological status of mangrove, salt mass, and seagrass beds. The blue carbon stock investigation has been carried out from 2021. The status of vegetation, plant carbon stock, sediment carbon stock, and littoral carbon stock are evaluated. On the basis of this, they also conduct pilot monitoring of blue carbon stock in Yangtze Estuary, Yellow River Estuary, and Caofeidian, and the relevant technical guidelines will also be established to achieve accurate estimation of national carbon sink capacity. Second, in terms of protection, an evaluation method for the importance of marine ecology protection was constructed, and the area of important ecosystem service of ecological vulnerability can be identified. On this basis, in order to strengthen the strict ecological protection, China started the reassessment and adjustment of the ecological red line in 2019, incorporating extremely ecological important area in red line, as is shown in the case of Tianjin. Through the ecological red line, typical ecosystems such as mangroves, seagrass bed, and salt marshes are all being protected, and mangroves is promoted from 73% to 98%, and seagrass bed is promoted from 81% to 96%. We also put many effort on the coordination of human activity inside the wetland area, such as coastal tourism, agriculture, and targeted control measure will be put forward. Besides, we also carry out evaluation of suitability of marine activities to better understand current status and endowment characteristic of resource and environment, and conduct pilot delineating of marine two space and one inner wetland. Two space refer to ecological space and development utilization space, and the wetland refer to the wetland area inside the ecological space. It is an optimized spatial layout for marine development and protection, and can guarantee further protection and restoration. Third, in terms of restoration, during 2015 to 2020, a total of 23,000 hectares of coastal wetland have been restored. The figure shows that location of 51 projects of the Blue Bay restoration and the coastal protection and restoration projects. Through the restoration project, the carbon sink capacity of mangrove, seagrass bed, and salt marshes can be consolidated. In the process, technical guidelines such as marine ecological restoration technical guideline, coastal ecological restoration for hazard mitigation technical guideline, and the mangrove ecological restoration manual have been formed to scientifically guideline the ecological restoration work and improve the restoration effectiveness. Since 2020, Chinese government has issued national action planning on ecological restoration and plan to restore the no less than 20,000 hectares of coastal wetlands, including a forest of foresting 9,050 hectares of mangroves. Both in terms of carbon trading practice, in 2021, China's first blue carbon project, Guangzhou Zhanjiang Mangrove afforestation projects passed the VCS and completed the trade. At present, based on the methodologies of CDM and VCS, China is developing mangrove, seagrass bed, and salt marsh carbon sink project methodologies and conform to international rules and the actual situation of China, combined with the long-term monitoring of mangrove carbon sinks. The methodology of mangrove projects was compiled, and the pilot application of the mangrove restoration project in Luoyang, Jiangsu province was carried out. At last, in terms of basic research, we released research work as early as 2016 and established a special research working group on blue carbon. In 2021, the Ministry of Natural Resources organized 14 related institutes to conduct a special study on blue carbon monitoring and evaluation, accounting, trading, and low carbon development. At present, we are compiling the marine ecosystem carbon sink work plan to strengthen the top-level design of released work. Local government and the scientific research institute are also actively carrying out released research. For example, Guangxi and Shenzhen respectively released the technical regulations for carbon sink capacity assessment of mangrove wetland ecosystem and the guideline for ocean carbon sink counting. Chinese Academy of Fisheries Science, Chinese Academy of Science and other institutes carried out simulations, analysis of, and quantitative evaluation of carbon sink, mechanism of shellfish agriculture. Xiamen University and some other universities have carried out simulation and evaluation research on the theoretical model of microbiological carbon pump in the South China Sea. In the next step, China will continue to carry out in-depth research and practice in the field of blue carbon. The first is promote important scientific knowledge of ecosystem, consolidating the foundation for early warning and monitoring, and develop the methodologies for ecological type list and ecological mapping in coastal area. At the same time, expand the investigation area and scientifically evaluate the capacity of blue carbon. The second is to strengthen the ecological protection and the management, improve analysis and evaluation methods, scientifically arranged at the marine spatial pattern to guarantee the space for blue carbon. Third is to expand the magnitude of ecological restoration of blue carbon ecosystem and strengthen the evaluation and the supervision of restoration effectiveness. Fourth is to continuous deepen the theoretical research and actively expand blue carbon practice and to establish and improve the diversified investment mechanism for blue carbon. In addition, China is also actively constructing bilateral and multilateral cooperation in the field of blue carbon. Currently, we are now preparing for the World Coastal Forum together with the CMS, Secretary of Ramsar Conservation Vision, IUCN, BirdLife International, etc., promoting to global protection and the restoration of wetland. We are also looking forward to more cooperation with the member of PEMC in the field of blue carbon, so as to jointly promote the ocean to better cope with the global climate change challenge. Thanks.
Thank you, Dr. Lu, and thank you for elaborating on China's blue carbon initiatives in support of the country's goal of becoming carbon neutral by 2050, including its activities on coastal and marine protection and restoration, and researches on blue carbon trading, accounting, monitoring, and evaluation, among others. The next speaker from Japan sent a pre-recorded message as he could not join us today. Ladies and gentlemen, kindly direct your attention to the video from Mr. Nobuhiro Hirashima, Director for International Ocean Affairs of the Ocean Policy Division of the Policy Bureau of Japan's Ministry of Land, Infrastructure, Transport, and Tourism. Should there be any questions on his presentation, please send them in the Q&A box, and we will endeavor to respond or send it to the ministry, whose response will be incorporated in the proceedings of the event. Ladies and gentlemen, kindly direct your attention to Mr. Hirashima's video.
Good morning, ladies and gentlemen. My name is Nobuhiro Hirashima. I'm in charge of Ocean Affairs at the Ocean Policy Division of MLIT Japan. Thank you very much for giving us this opportunity. I would like to speak about Japan's plan for implementing ocean-based solutions in response to global climate change. At first, I'd like to explain Japan's intention to aim for carbon neutrality. In October 2020, Prime Minister declared that Japan will go carbon neutral by 2050. He also stated that some points to realize a carbon neutral society. Firstly, we need to adjust our mindset to a paradigm shift that proactive climate change measures bring a dynamic economic growth. Secondly, we will accelerate research and development aimed at realizing utilization of key technologies for carbon neutrality. Thirdly, we will advance green transformation more efficiently and effectively through digital transformation. Furthermore, he also announced a target of reducing Japan's greenhouse gas emissions by 46% in fiscal year 2030 from the fiscal year 2013 levels. This slide shows the green growth strategy for carbon neutrality, which was established by Japanese government in 2020. This strategy is an industrial policy towards positive cycle of economic growth and environmental protection and contains some key factors, such as the government presents a concrete national vision and goals which motivates business players. This strategy provides a reference on both the energy policy and energy outlook for 2050 carbon neutrality. This will constitute a list of 14 sectors with high growth potential, for which the government will provide necessary policy measures and show ambitious goals. This slide shows action plans in key industrial fields. Action plans of green growth strategy were established in the following 14 key industrial fields, where future growth is expected and efforts are essential to achieve 2050 carbon neutrality. In this chart, these fields categorized with energy-related industries, transport manufacturing industries, and home office-related industries. We have started actions from those required actions in current introduction and expansion phase to others for future research and development phase. This slide shows action plans and concrete measures in ocean sector. Number 1 is offshore wind power generation industries, which contains creation of attractive domestic market, promotion of investment and formation of supply chain. Number 2 and 7 are about shipping industry, which contains conversion to carbon-free alternative fuel ships, namely zero-emission ships, and development of international frameworks to promote low-carbon ships. Number 8 is logistics industries, which contains formation of carbon-neutral port, which realize net zero greenhouse gas emissions through decarbonization of port functions, utilization of next-generation energy sources, such as hydrogen and ammonia, and so on. Number 9 is food, agriculture, forestry, and fisheries, which contains absorption, fixation of CO2 as blue carbon, namely carbon sequestration by marine ecosystems. Thank you very much for your attention. With regard to the issue of global climate change, if human beings do not take countermeasures against CO2 emissions, temperatures are expected to rise around 4 degrees at the end of this century. As natural disasters become more frequent and more severe worldwide, reducing CO2 emissions is one of the most important factors in the global climate change. We believe that the role of the oceans in addressing global climate change is very important. We would like to contribute in implementing ocean-based solutions in response to global climate change. Thank you.
Thank you, Mr. Hirashima, for presenting Japan's plan, strategy, and action in transforming its ocean sector into a carbon neutral sector by 2050, as covered in the implementation of Japan's green growth strategy. Our next speaker will also deliver a pre-recorded message. Ladies and gentlemen, let us welcome Ms. Elenida Basug of the Philippines Department of Environment and Natural Resources. She is the OIC Director of the Climate Change Service and concurrent Director of the Department's Gender and Development Office. She will be represented by Mr. John Eric Avellino, OIC Section Chief of the Biodiversity Management Bureau in the open forum later on. Ladies and gentlemen, please direct your attention to Ms. Basog's video.
Good morning, ladies and gentlemen, officials from various national and local governments, guests from civil society, research institutions, academe, non-government organizations, and the private sector from the different East Asian countries, to our organizer from the Partnerships in Environmental Management for the Seas of East Asia, or PEMSE. Happy World Oceans Day with our theme, Revitalization, Collective Action for the Oceans. Our warmest greetings from the Philippines. I speak here in behalf of DNR Undersecretary Annalisa Te. I would like to thank PEMSE for allowing us to share initiatives and opportunities for ocean-based climate action in the Philippines. And as I do that, here will be my outline. First, I will be discussing briefly the state of the oceans in the Philippines. Second, I will briefly describe the frameworks in incorporating blue carbon in national deterrent contributions and climate change-related policies in the country. Third, I'd mention about harnessing blue economy in the country. And fourth and last, mention a bit of the ways forward. The East Asian Seas region is known as the global center of marine biodiversity and endemism. It hosts one of the most diverse and richest marine ecosystems in the world, and as such, is considered as a global hotspot for biodiversity conservation. The coastal and marine tourism alone contributed around $3 billion in value added, with around 900,000 employed in this sector, while the fisheries and aquaculture contributed $2.37 billion in value added, or 1.5% of the gross domestic product in 2016, with 260,000 employed in this sector. The ports and shipping industry contributed $1.4 billion in value added, employing around 700,000 people. The region's marine ecosystems, however, are also known to be one of the most threatened by an array of drivers, especially climate change. From the years 1990 to 2006, the estimated cost of damages to agriculture and fisheries on average annually is around 12.43 billion pesos, of which 70.3% was caused by typhoons, 17.9% by droughts, and 5% by floods. The Center for Research on the Epidemiology of Disasters recorded 187 significant damaging natural disasters in the country in 2007 up till 2016, causing the death of 16,262 people and injury to about 168,114 persons. They affected more than 100 million individuals in the country during this period, and the socioeconomic damages are estimated at $19.16 billion. Based on a study by the Asian Development Bank, the country is estimated to lose 6% of its gross domestic product every year until the year 2100 if it disregards the risks associated with climate change. However, if the country starts investing on climate change mitigation measures by 2020, it is estimated that it can reduce the losses by up to 4% by the year 2100. This coming from the Climate Change Executive Briefs in 2018. The unsustainable use of marine resources greatly impacted the health of our oceans, seas, and coasts. The COVID-19 pandemic has also exposed the vulnerability of the global waste management system, which brought on environmental collateral damages, particularly to our oceans. Several pressures and challenges in the Philippines oceans include pollution, habitat and biodiversity loss, economic costs, risks from climate change and natural hazards, and fragmented ocean governance. Through the Executive Order 533, signed in 2006, the Philippines adopted the Integrated Coastal Management as a national strategy to ensure the sustainable development of the country's coastal and marine environmental resources. It also established supporting mechanisms for its implementation, such as integrating ICM into primary and secondary education curricula, ICM training program for local government units, environment and natural resources accounting valuation for integrated coastal management planning, and establishment and maintenance of a coastal and marine environmental information management system and framework. A resolution was signed creating the Blue Carbon Steering Committee and the Blue Carbon Technical Working Group of the country. The Blue Carbon Steering Committee is comprised of government agencies that set the policy direction, while the Technical Working Group consists of government agencies, civil society organizations, academic institutions, and the private sector to undertake and promote research in blue carbon. The Climate Change Commission resolution reiterated the Philippines' intention to harness the adaptation and mitigation potential of blue carbon, which was included in the subsequent submission of the National Determined Contribution. The Technical Working Group also provides technical assistance and advice to the Steering Committee and the Cabinet Cluster on Climate Change Adaptation, Mitigation, and Disaster Risk Reduction for the development and implementation of a national blue carbon initiative. The Coastal and Marine Ecosystems Management Program of the Philippines Biodiversity Management Bureau is one of the climate change adaptation measures identified in the Philippines NDC. It aims to comprehensively manage, address, and effectively reduce the drivers and threats of degradation of the coastal and marine ecosystems in order to achieve and promote sustainability of ecosystem services, food security, and climate change resiliency for the benefit of the present and future generations. Recognizing the interconnectivity and interdependence of human society with our coastal and marine environment, the program has 7 components as shown in this table. On marine protected area network establishment and strengthening, the program links small and locally managed marine protected areas with each other based on the connectivity of the habitats they host and influenced by ocean currents. The networking and scaling up of local management and protection initiatives allows for collaboration between LGUs from the use of resources such as boats, sharing of knowledge on local and regional environmental threats, even scaling up good environmental management practices and campaigns across a larger area. CEMEM that supports and incentivizes the development of biodiversity-friendly enterprises is among our coastal communities. These are small, medium-sized businesses or enterprises run by people's organizations or coastal communities that provide livelihoods through the sustainable use of biodiversity and natural resources. In 2020, 150 biodiversity-friendly enterprises were provided with technical assistance. 33 people's organizations were provided with financial assistance amounting to 37.8 million pesos. It's targeted that by 2028, 70% of our people's organization enterprises in the biodiversity-friendly enterprise master list will be recognized as full-fledged BDFE. Protected areas Development and Management Program is also part of the climate change adaptation measures in the Philippines National Determined Contribution. This covers the main EC2 measures to conserve biodiversity within and adjacent to protected areas. This is the comprehensive set of activities designed and being implemented to ensure sustainable management of protected areas. The Manila Bay area is the Philippines' major center of economic activity. With the various developments taking place in and around the bay, the natural environment is facing threats from overpopulation, pollution from land and sea-based sources, over and illegal fishing, uncontrolled development, loss of habitats, and decreasing resources. In 2019, the Battle for Manila Bay was launched in compliance with the Supreme Court and mandamus. Water quality in the Manila Bay Walk area and Baseco Beach has significantly improved to the activities that we're seeing here on the screen. Expansion of wastewater treatment facilities within their coverage area by 2037 is also one of the climate change mitigation measures identified in the Philippines NDC. Blue carbon initiatives in the country that can be scaled up include: 1. Sustainable fisheries and aquaculture. It has been estimated that the cost of achieving Sustainable Development Goal 14, or life below water, globally is $114 billion annually. Of this amount, the greatest resources, 87 billion US dollars annually. Of this amount, the greatest resources, or that of 87 billion US dollars, is for combating marine pollution. 40 billion US dollars is for ecosystem protection, and 28 billion US dollars for fisheries. Hence, sustainable fisheries and aquaculture is very crucial, and this include: 1. Adaptive aquaculture supplemental livelihood programs for fishers, such as the Philippine National Aquasilviculture Program, which is focused on replanting of destroyed mangrove resources. Second would be the integrated multi-species aquaculture. And third, electronic catch documentation and traceability, which uses modern technologies and allows networking of national information systems and provides interface that will allow system users to input traceability throughout the supply chain. While marine and coastal tourism emerges as a promising source of income, it requires careful management to ensure the protection of the coastal and marine habitats, resources and water quality, as well as sustainable development of communities. Sustainable tourism takes full account of its current and future economic, social, environmental impacts, addressing the needs of visitors, the industry, the environmental, and host communities. And this could be including the management of marine protected areas and ecotourism, ensuring responsible diving operators, the use of wastewater treatment and reuse in resorts, and implementation of zero carbon resorts and green hotels. Many of the challenges in the conservation and sustainable use of oceans and marine resources lie in the transboundary and highly complex nature of ocean management. This is coupled with the fragmented understanding of the interaction between oceans and human activities. The dearth for Goal 14 can be attributed to insufficient global methodological development, limited country-level experience in collecting ocean data, and high cost of collecting data across the exclusive economic zones. What then are our ways forward? Regional cooperation supports the enforcement and monitoring of international conventions, frameworks, norms, and standards by providing the required technical support where needed. Strengthening inclusive and action-oriented regional platforms such as the Asia-Pacific Day for the Ocean offers a pathway for establishing meaningful partnerships, effective follow-up and review, and inclusive sharing of experience across stakeholders and countries. This crisis that we are all unfortunately confronting provides us the opportunity to rethink, reevaluate our directions, our choices for the economy, for the environment, for humanity. We need to analyze our responses to academic through a climate lens. We need to pursue transformative actions for the oceans. We can in fact convert this crisis into opportunities to accelerate climate action and build back better, greener, bluer, and healthier. Thank you, ladies and gentlemen, for listening.
Thank you, Ms. Basug, for sharing the state of the ocean in the Philippines, the national framework in incorporating the coastal and marine sector in the country's nationally determined contributions, and climate change-related policies, as well as the country's programs and nature-based adaptation measures in the coastal and marine sector. We will now be having a 10-minute break, and during this time, I would like to remind the participants to please fill out the attendance sheet provided in the chat box. Do follow us on our social media accounts indicated also in the chat box for similar events and updates on PEMC's work in the East Asian Seas region. See you all after the break. Welcome everyone to the second leg of our country presentations. Hope everyone feels refreshed and managed to stretch their legs and arms during the break. Again, a heads up to our participants, you may submit your questions to our speakers through the Q&A box here in Zoom. We will also be entertaining questions from those joining us via live stream. When asking, do share your name and affiliation and address your questions to a specific speaker if possible. So our country speakers, kindly note of the 10-minute allocation. Our next guest is from RO Korea. Ladies and gentlemen, let us all welcome Mr. Jin Woo An, Deputy Director of the Marine Environment Policy Division of the Marine Policy Office of the Ministry of Oceans and Fisheries. Mr. An, the floor is yours.
Appreciate for introduction. Distinguished guests, ladies and gentlemen, my name is Jin-woo An, Deputy Director of Marine Environment Policy Division of the Ministry of Oceans and Fisheries of the Republic of Korea. I think it's very important that we are having this discussion on the ocean and climate change in the East Asian community. That is, these countries are both the keepers of mangroves, salt marshes, and tidal flats with large marine territories where ocean-based solutions shall be very effective. Before I begin, I'd like to express my gratitude to the delegations from different countries and various NGOs for your presence today to talk about our oceans and climate change. My presentation today will mainly discuss the ocean-based solutions to respond to climate changes that are being promoted in Korea. Building onto the UNFCCC COP26 meeting in November 2021, Korea has set up the 2030 NDC to be 40% of the 2018 level. In addition, Korea ranked 14th in the world to adopt a legal framework under the vision of 2050 carbon neutrality and mechanisms, and its legislation took effect in March 2022. In particular, the fields of oceans and fisheries. As of December last year, we established the 2050 carbon neutral roadmap for oceans and fisheries, which aims to achieve the carbon negative goal by the end of 2050 by cutting down the greenhouse gas emission from shipping and fisheries industries. We will also expand the use of oceans as carbon sinks as well as the scope of application of ocean energy. In order to reduce greenhouse gas emissions in the shipping and fisheries sectors, we plan to promote the development of low carbon as well as carbon-free shipping technologies powered by green fuels such as hydrogen and ammonia. By doing so, a proper port environment for operating eco-friendly ships will be established. Thus, it will accelerate the conversion of fishing vessels as well as merchant ships. And this will help us become more environmentally friendly. In addition, we plan to make the best use of various marine energy sources, such as such as tidal power, wave power, and tidal currents. This will not only generate electricity efficiently, but to produce green hydrogen as well. However, the most notable climate change response system is ocean-based solution through blue carbon. According to several scientific studies, including the IPCC, oceans are rich in carbon sinks with its large scale, which has the remarkable absorption capacity up to 30% of post-industrial greenhouse gas. Korea is making plans to put to use great possibilities of what ocean sinks can offer by including tidal flats and sea forests to realize the 2030 NDC, which were announced after amendments in 2021. Tidal flats in Korea were selected as a World Natural Heritage Site in July 2021. And according to a study conducted by Seoul National University, carbon absorption by tidal flats exceeds 200,000 tons on an yearly basis. This is why tidal flats are gaining attention as treasure troves of coastal ecosystems and potential carbon sinks. In the past, we mostly focused on recovering the ecosystems of tidal flat by restoring the areas which used to be full of abandoned salt and aquaculture farms. However, from this year, we have launched the restoration of the vegetation area of the tidal flats, which are namely salt marshes. 4 sites, including Sinan, 전라남도, and Seosan, 충청남도, have been selected as target sites of restoration. And the eco-friendly restoration of the halophyte community in the upper parts of the tidal flats will help to improve the health of these ecosystems as well as their potential as carbon sinks. Also, an implementation plan for the expansion of sea forests has already materialized. By selecting vegetation that is highly adaptable to climate changes and is suitable for the characteristics of each sea areas. We plan to create sea forests that is a total of about 39,000 hectares by 2030. At the same time, Korea aims to move toward enhancing the health of the sea by preventing sea desertification and improving the adaptability of marine ecosystems to climate change. In this respect, ocean-based solutions are very useful not only in the context of carbon sinks, but also as a means of adaptation to climate change in coastal areas. As for Korea, 27% of its population live in coastal areas, so it's necessary to prepare and prevent coastal disasters such as coastal erosion and flooding caused by climate change. For this to happen, we plan to create climate adaptive coastlines. As for the United States and Australia, I fully recognize they have already been making investments in helping to improve the biodiversity and climate resilience of the coastlines through the restoration of artificial structures on coastline as habitats for halophytes or the creation of breakwaters using eco-friendly materials. As part of each action, Korea will launch R&D projects to build coastlines that apply eco-friendly construction methods starting this year. And in 2030, we plan to implement climate adaptive coastal development projects in coastal areas at a national level. In the past, forests were the only resources that we have to use as carbon sinks against greenhouse gas emission, and we sold regions as there were no better alternatives. Oh, I'm sorry. But there has been a change in thinking, and now there are many discussions on ocean-based solutions to climate change on the level of various global governance. Although the ocean-based solutions are in early stages, research is beginning to show positive outlook. From tidal flats and algae in Northeast Asia, mangroves in Southeast Asia, to various ocean sinks that have not yet been studied in East Asian waters, the potential is limitless, and such promise is not just limited to carbon sinks whose absorption capacity is certified by the IPCC. In addition, I think that the improvement of coastal climate adaptability is worth exploring as well due to the nature of East Asia's geography, where coastlines are complicated and heavily damaged from climate disasters. I hope the East Asian community will become a body in this region that together will defeat climate changes with the help mostly from our oceans. This will happen when we build solidarity and discuss common solutions centered on ocean-based measures to address climate change issues. Korea is keen to work with others and put our heads together with any country in East Asia to come up with ocean-based solutions to help solve climate issues. Thank you.
Thank you, Mr. An, for elaborating on RO Korea's ocean-based solutions in response to climate change, particularly the implementation of the country's roadmap to carbon-neutral oceans and fisheries sector by 2050. We now move on to our next speaker. Our next speaker is Professor Dale Barker, Director of the Center for Climate Research, Singapore. Ladies and gentlemen, please welcome Professor Barker.
Good morning, everybody. My name is Dale Barker. It's a pleasure to be here. I'll just share my screen. Okay, yes, great to be here. So I'd like to spend 10 minutes talking a little about climate solutions, but I'd like to end up with a bit of a talk about the underpinning climate science that we need, of course, to inform the investments in climate adaptation. Excuse me. So yeah, just in terms of blue carbon, I just wanted to start off with a slide you probably, or a table you've seen before from a paper from Nature a few years ago. And in terms of blue carbon, the various parts of the ecosystem: mangroves, tidal marshes, seagrass, and seaweed. And just across the top, of course, there are the various aspects of climate change which impact on the blue carbon. I'll talk about some of these, but of course you can see sea level rise, extreme storms, higher temperatures, extra CO2 and altered precipitation. So a lot of it is about, of course, the weather, storms, temperatures and precipitation. But of course, the sea level rise, the mean sea level rise is a key aspect too. And so it's really that climate science, how the climate and the physical climate system is changing is the priority of the work in CCRS rather than the solutions per se. But in terms of all those various sources of blue carbon in Singapore, it's a relatively small place, as you're aware. Mangroves is probably the number one, and there are some significant activities building up in terms of mangroves as part of defences as well as parts of sources, sinks for carbon. So the mangroves are about 1% of total area of Singapore. And as you can see, a lot of the mangroves have gone away in the past 50, 60 years or so, but they're very efficient in terms of storing carbon, as we're all aware. And some numbers there, excuse me, in terms of the amount of carbon that can actually be stored by that amount. It's quite significant in terms of the carbon production of people, 620,000 or so. So again, mangroves is the focus. And in terms of solutions, there is a new Centre for Nature-Based Climate Solutions at the National University of Singapore, where they're investigating both potential restoration of mangroves as well as the studies of how they might be part of the solutions in terms of coastal protection. So in terms of reality, what's happening and what's going to happen as far as we talk about the sea level rise aspect of the impacts on the mangroves and other things such as coastal protection. The left hand picture is essentially the sea level rise over the past 30, 40 years or 50 years or so. And at the bottom, you can see, of course, various differences between the various parts of Singapore. But point to make there is the rate of sea level rise in Singapore has accelerated from about 1.5 millimeters a year up until about 2009 to triple that in the past 20 years or so. So this is accelerating. And I think we're fairly clear on what the reasons are there in terms of the global mean sea level rise, etc., rather than the vertical land movements, for example, in Singapore. And I think if you look at the future, these are some of the projections we've produced based on the local studies, as I'll come back to later. And again, you can see again going forward, mean sea level rise projected to rise by up to a meter by 2100. That's the mean. So you need to add the impacts of the weather, the storm surges, etc., to that, and then you get to a figure of 4 or 5 meters potentially for extreme events. So these are the figures we need to be planning for. And again, these significant impacts on mangroves, for example. You know, how quickly that happens depends on how feasible mangroves are as a solution to coastal protection. Depends on how quickly that happens. Mangroves can only grow so quickly. So, but there are the figures in terms of sea level rise. So just a slide on CCRS, the Centre for Climate Research Singapore. So our mission is to advance scientific understanding of the underpinning climate science change from all and the weather system affecting not just Singapore, but the wider Southeast Asia region. And just in terms of the bullets at the bottom, we were looking at operational weather forecasts for this region. You can see the animation there, which is a probability of precipitation at very kilometre scale. Grid spacing. Singapore's quite a small place, and the weather is quite small scale in this region. These storms are quite localized typically, so we need to go hone in on the grid spacing quite high. So as well as that, of course, we're talking about climate change and the models we use for weather prediction. We're also using for regional climate projections. So we're using this, for example, in our latest V3 project, which will provide the next generation of projections on regional climate change, which will inform the solutions and adaptation activities. So in terms of just the third national climate change study, I just like to advertise this. Of course, as you can see the domain from the top right, it covers pretty much the whole of Southeast Asia. This is what they call this Cordex domain. So there'll be regional climate projections going out to 2100 and possibly further 8 kilometre over that wider area and 2 kilometre over the smaller area you see in the black box in the middle there. So it's using the latest climate models using IPCC, what known as the CMIT-6 models, using the latest weather and climate regional models that, again, we use day to day in operational weather forecasting. And you can see the impact on the resolution at the bottom right. As you can see, Singapore is a fairly small place. So even at 2 kilometers, you only have so much fidelity of the regional patterns from weather and climate projections, and 8 kilometers even less, of course. So we can't necessarily get down to the detailed, the mangroves, the impacts on the meter scale coastal inundation, but that's still done in a statistical way. But again, this is the next generation, so we were fairly pleased with that. So just moving forward, I want to come back to, I'll send a couple of slides on the science and then come back to the solutions. And the way we're seeing this, of course, the climate science in the yellow box, if you look to the top left, is underpinning, well, it provides inputs from the mitigation plans from the various scenarios, the SSPs that we use to try and understand how society is going to react to climate change in terms of mitigations. And it also deals with what are the various impacts, what are the climate adaptation activities that we need to plan for, what are the solutions we need to plan for. And what we're trying to do here is, as you can see at the top, you've got the various clusters, the solutions, whether it be flood protection or urban heat or biodiversity, greenery, aquaculture, for example. Public health, dengue fever, for example, is a top topic here in Singapore at the moment. That's somewhat dependent on the climate. So a whole variety of applications that are impacted by climate change. But what we know, and underpinning that all, is the same climate system. It's the same physical climate system. So that the rainfall that affects flooding is the same rainfall that impacts urban heat, or biodiversity. The types of trees that might grow depend on the rainfall and the temperatures, for example. So the underpinning science is common. We don't necessarily need to have different models and observations for the different applications. So our focus is on, in that V3 study and beyond, to have the underpinning data that can feed all of these applications, including, for example, blue carbon. And for that, we need what we call enablers. Observations, satellite-based observations, surface-based observations, our models, our supercomputers, and our people, of course, to do the work. And just to plug here, Southeast Asia, we have a bit of a concern. In terms of the ocean, Southeast Asia is one of the most data-sparse areas in the global ocean for example, Argo floats and surface buoys. And so, we can't do the science particularly well without observations. So I think there are some activities to try and coordinate potentially field campaigns or operational climate monitoring systems in the South China Sea, for example. That's quite challenging, but again, we can't do too much without observations to validate and understand the processes. So that is a particular thing to flag up in Southeast Asia. So in terms of the models that we'll use to produce the data to drive the solutions, this is a really interesting part of the world. Southeast Asia is known as the maritime continent. This is the maritime continent part of the world. In global climate science, it's known as the engine room of the global climate system. So it's not what happens here doesn't just impact us, it impacts what happens elsewhere in the world as we know from the La Nina, the El Nino circulations, etc. So, but what that means is we need to not just treat the weather separate from the ocean. So our ocean models, projections of changes in the ocean, need to be coupled to the weather and vice versa. And so what we're moving towards now, what we call coupled systems, where if you look to the bottom right, we're not just doing the weather forecast, that's the red box. We're also we need to understand where that rainfall goes in terms of the river flows, and it eventually ends up in the oceans, and that brings the sediments with it, the pollutants with it, and of course the waves are there impacting on the sea level. So again, this is a holistic coupled system. The true climate system is a coupled system, and so our models and our understanding needs to reflect that coupled nature. Biogeochemistry in there, for example, the ecosystem is part of it, is an integral part of that climate system too. So that's essentially the next generation when we go to in 4 or 5 years' time, the regional climate projections that we'll be producing for Southeast Asia will include the ocean, they will include the waves. Currently, they're essentially sea level rise plus the atmosphere, but not too much detail on the ocean in terms of the ocean, which is what we really need for some of these blue carbon applications. So I'll finish up with 2 slides on one particular activity that's underway, and it's led by the NParks agency within Singapore. So this is funded by the National Research Foundation, the Marine Climate Change Science Program. It's a total of 25 million to support a 5-year program to essentially look at the marine climate science and solutions as part of that activity. So I won't dwell on all the words, but essentially it's building on previous activities such as the Marine Science R&D program, And again, it's part of the Singapore's solution or response to as part of the Singapore Green Plan 2030. So if I just finish with one slide, and I'm running out of time, but again, in terms of how the Marine Climate Change Science Programme is the objectives, how it's split up. As you can see, there are various solutions applications. Blue carbon is one, of course. We talked a little about the mangroves in Singapore. That will be a key focus. But eco-engineering, eco-resilience are two other what we call verticals. Again, there are particular applications and solutions in mind. My area is climate science, so I'm not an expert on blue carbon or eco-engineering or eco-resilience. But what we do in CCRS is develop the underpinning science, and through marine climate impact, H1, as you can see here, that's how we translate the underpinning science into the solution. So it's the experts on the climate science working with the experts in blue carbon through climate impact research. So that's essentially the overview of the MCCSP. And again, I think that's probably all I need to say, and I'll stop there. Thank you very much.
Thank you, Professor Barker, for that very informative presentation on the Center's climate science researches in support of a better informed adaptation measures and policies. We would like to inform everyone that due to technical issues that we are encountering from our speakers in Lao PDR and Vietnam, we'll now be proceeding to the open forum. We are very fortunate to have with us one of our honorary alumni as our moderator for this morning's open forum, Dr. Antonio Lavinia, former chair of the East Asian CIS Partnership Council and Associate Director for Climate Policy and International Relations of the Philippines Manila Observatory. Dr. Lavinia, the floor is yours.
Thank you, and good morning to everyone. I'm very happy to be back here and engage with all the colleagues from the partnership, from the region and all over the world. This is such an important topic. In fact, as we speak, there is a meeting going on in Bonn, Germany, the intersession meetings of the Climate Change Convention, and some of the topics that we have been discussing here actually up for discussion there as well. What I thought I would do first before we look at the question and answers, the questions that have been posted in the session, and we'll just go to that systematically. Is actually to start with a big picture, and I'd actually like to address that first to Dr. Kang from Korea, because you did present the basic ocean and climate links, the recent IPCC report. So, and what I'd like to ask is about what you thought would be the opportunities provided by the Glasgow Climate Pact for us in PEMC, the science, the ocean science and research communities in this region. Where are the opportunities? Where are the priorities? And maybe where's the comparative advantage of our region, of our institutions on these issues? So could we ask you to comment on this, Dr. Kang? I would have asked Dr. Yusof also to talk about local government and climate and national government, but I'll probably reflect on what he said myself after Dr. Kang. Thank you.
Well, thank you, and thank you for the question. And actually, the main things of the Glasgow Climate Pact, or the last meeting of the COP26, I think actually the marine environment and marine ecosystems are recognized as a very important part of our climate change. And this kind of recognitions, pushes some kinds of our dialogue like this ocean and climate dialogue could be persisted in the society. And I think the ocean itself is very important in our Earth's climate, and that kind of things drives us to do more of research or studies in the ocean science, especially for the role of the ocean on the climate change. And also we need to study some kinds of, the impacts of, or the vulnerability of the oceans induced by the global change. And as you know, the Ministry of Fisheries in Korea, Mr. An told that in Korea, we increased a lot of marine or ocean climate research fund and as well as the projects or programs. So we would like to focus on the not only for the global situations, but also the more intensified and sub-region problems of our coastal area as well. So in this case, I think the important thing is that the science should do some kinds of role on the service for the marine policymakers as well as general public to understand how the ocean is working. And yeah, in that sense, the Ocean Climate Prediction Center in Kiosk is also supported by the Ministry of Fisheries of Korean government as well. And the important thing is that the collaborations between the scientists and actually the ocean itself is we cannot make some kind of boundaries of our oceans. So the scientific study should collaborate with all the countries around us or surrounding countries of the ocean. So yeah, in the case, I think the periodical examinations and the share of the data, informations, as well as tools, that kind of things is very important for the ocean-based solutions for our actions to the climate change. Yeah, that's all.
Thank you. I'll give a follow-up question for you, Dr. Kang, and maybe actually ask Dr. Barker as well to comment on this as a scientist as well. There are stories about nature getting a breather during the pandemic. We saw that, and that includes in marine species being seen and water being clearer. Is this an accurate observation? And how can this be incorporated into, for example, the way we are developing our sustainable development plan for the partnership?
Okay. Yeah, I think the pandemic definitely contributed in some good ways to reduce greenhouse gases for the moment, especially in Korea. I experienced the fine dust level is surely lower than before. At least we found that human activities could change the situation, which is a good news, I guess. And this is a kind of evidence we choose in the future. But in other aspects, we used a lot of masks and the disposals during the pandemics, and that makes things a little bit worse than before. And also, people are waiting for the new activities. Actually, people they have some kind of how to say a bad feeling for that they lost something, their lives. So they would like to do something more after the pandemic, or if the pandemic is over. So it makes then this kind of things is kind of a tentative or temporary situations, and then maybe it would be it would work worse than before. But anyway, these kind of things drives us to develop sustainable development to make some kind of green energies and doing something for the in general people's level, and yeah, that could be important for us. And scientifically, we need to know this kind of the shutdown of some fossil fuel usage, how these kind of things affect to the real or especially marine environment. Then kind of things is also we would like to study again. Kind of a good research team, I guess.
Thank you, Dr. Camp. Professor Barker, would you like to share your thoughts about that as well as a scientist, and then I have a couple of other scientific questions for you.
Thank you. Yeah, related to the pandemic, I mean, it was obviously a very significant event for the whole world for a couple of days. I mean, we're only really just, of course, it's still here with us. It's becoming endemic, but I think the next 6-12 months in terms of adaptation, in terms of the ideas of people home working more or relying on video conferencing or hybrid working. There are elements there that it could have certainly in city environments, things like air quality, and it could have a positive. It could be a negative impact, but I think the jury's still out on where that's going to go. Are we going to back to the old normal, or is the new normal here to stay? I think it depends on the company or even the country where that's going to go. But I mean, there was we did notice obviously impacts on the science. So, for example, the improvements in air quality, which led to reductions in mortality for air quality in certain parts of the world. Of course, that again, can we hold on to those improvements? Probably not completely, but it's a motivation where you can see the cause and effect. You can see the impact of improving air quality on human health. I mean, that's clearly proved that from the statistics. On the flip side of that, of course, the fact that people were so in their own homes, etc. For example, dengue is one of the biggest outbreaks here it's ever been in dengue. It's big news in Singapore, and part of the reason for that, only part of the reason for that, is that people have been holed up and haven't built up their immunity to various serotypes over the past couple of years. So there are negative impacts. People need to get out and mix to maintain resilience and defenses against the viruses that we see in our everyday lives. So I think they're examples on the science. I think it's in our global weather forecasting systems, of course, we lost all the aircraft. So one of the first things we found for those who are trying to predict the weather that leads to these extreme events is we lost all the aircraft data, and that, of course, all the aircrafts were not flying anymore. And so actually the global weather forecast quality went down for a little while because of COVID, which is one of those impacts you wouldn't expect. But of course, the climate and the weather, they're linked to human in so many different ways that you see all sorts of indirect effects like this, which cause us to think of things in different ways. But so just a few thoughts there on pandemic and climate.
Thank you. That's very insightful, Professor Barker. I have another question. We actually have that in the question and answer box regarding climate model grid size. I mean, how small scale do projections have to be useful for planning and prevention?
Thank you. That's a really good question. I think it's partly what information you're trying to get, and the ways, the scientific methods you use to get that information will differ. So, for example, as we know, the global climate models really only provide a very broad scale estimate. So, we know the impact on Greenland or Antarctica and the Southern Ocean, but the detailed impact on Singapore, well, we can't tell that from IPCC, of course, in current generation IPCC. So in a small place like Singapore, of course, again, there are general trends such as temperatures, which don't vary that much in Singapore, and half a degree won't make too much difference. And in fact, in places like Singapore, it's not so much about climate change with temperatures, it's about urban design. So, climate change may be a degree, but urban design is 4 or 5 degrees potentially in terms of difference it makes. So climate change is part of, when it comes to urban environment, those scales of cities, then it's not so much about climate change in big cities. Actually, it's about urban design, using cool paints, for example, to keep, you know, angling the buildings in a certain way, putting in green space, putting in reservoirs to mitigate against temperatures, and much more. And they're dealing more with the urban heat island than they are with CO2 induced temperature rises. But coastal protection, coastal inundation, for example, you know, of course, that's very local. If one is looking at the impacts of waves on a very small place like Singapore, then you have to get down to meters or tens of meters. And the science is very, very immature on that in terms of the modeling. Of course, observations, we don't have too many. So I think at the moment we're just, and what we're trying to do in Singapore is trying to get down to kilometer scale, where we can at least start to see the weather features that lead to the rainfall. Sumatra squalls or the convex localized rain thunderstorms, we can start to see those now. So we're starting to, they have sufficient resolution. Of course, having higher grid spacing is going to improve the accuracy maybe, but at least we're starting to see them. And as I frequently say, that the global climate models don't even see Singapore. All right, they're at 7,500 kilometers, but they don't even see Singapore. So, you know, it depends on the area you're considering and the weather you're considering. But we think around a kilometer scale is where the science is at in terms of the models. And to get down below that, you're really looking more at sort of statistical techniques and empirical techniques.
Thank you, Professor Barker. There's a question here for our colleague from Vietnam about vulnerability to climate change and particularly in the eastern coastal area bordering the South China Sea and how it's implemented. Is from Pak Ewan of the Ministry of Environment and Forestry. We'll communicate this to our Vietnamese colleagues so they can answer it, and we'll put it in the proceedings. There's also a question about carbon sequestration, the computation for marine conservation, but I think that's a proper question for this afternoon's session. If you don't mind, I'll skip that for now. So let me go now to our colleague from China, to Dr. Liu. There's a question here on your presentation regarding wetland coastal restoration efforts. Can you share more? It's really, I found it fascinating, and it would really be good to see what strategies work and how it can be scaled up in other parts of this world. Thank you, Dr. Liu.
Okay. Ministry of Natural Resource organized project applying every year about 5 billion RMB per project, and the technical guideline for marine ecological restoration has been prepared based on many theoretical research and long-term practical experience. The guideline specified the main roles, principle, requirements, and technical rules of restoration, including 6 typical ecosystems of mangroves, salt marshes, seagrasses, seagrass bed, seaweed bed, coral reef, and oyster reefs, as well as 4 complex ecosystem of tidal flats, estuaries, bays, and sea islands. Guideline had promoted to conduct the restoration project more scientifically and properly, and to guarantee the restoration effectiveness and the normalization, avoiding such issues as ecosystem harm or coast waste. Limited by the scientific knowledge, there are still rooms for the improvement. On the basis of this, we will continue to strengthen the basic research and the technology innovation, especially on the key exploration technologies and of blue carbon ecosystem, such as suitability evaluation of restoration area, blue carbon ecosystems, and exploring synergies of ecosystem service among coastal wetlands protection and restoration, coastal protection, biodiversity protection, and the carbon sequestration. Okay.
Thank you. I have a follow-up questions, if you don't mind, Dr. Lu, and this is about sorry, this is about the technical guidelines for marine ecological restoration, and you've been testing this. How so far has this been successful, the pilot restoration efforts, and are there other initiatives similar to this? It's just always fascinating for me to hear all the initiatives that China is doing in this area.
Okay, the guideline about the ecology restoration is published in the last year. It's based on the knowledge of the specialist and the practical experience of the scientist. So it can be applied to the just applying and avoid the cost loss and avoid the wrong direction of restoration. Okay.
Okay, thank you. Let me go now to the Philippines, and while we don't have Ms. Basug with us, we have actually representatives from the Philippines. I think Mr. Avellino will be joining us. Yeah, hello, kumusta po? Welcome. You know, Ms. Basug, Mr. Avellino mentioned that there is a coastal and marine ecosystem management program for climate change adaptation in the Philippines and the sea, and I'm actually aware of that. The MPAs are emphasized also as important for tourism. So can MPA management include blue carbon efforts, and have you done that? And how does it help manage climate change?
Yes, definitely.
Audience.
Yes, definitely. Dr. Lavinia, thank you for that question. So the Coastal and Marine Ecosystems Management Program anchors its components on the establishment of marine protected areas. But moving forward, in order for us to contribute to climate change, of course, climate change adaptation and mitigation, of course, we recognize that our coastal ecosystems actually sequesters more than our terrestrial forest in terms of carbon sequestration. So that's why our focus on the Coastal and Marine Ecosystems Management Program, or CMEM for short, is really trying to scale up marine protected areas, moving away from the traditional establishment of individual MPAs, but rather moving towards making it more efficient, making it more effective by networking, not just through intergovernmental, but even through transboundary marine protected areas. That way, we would be able to protect and conserve our coastal and marine habitat, particularly coral reefs, seagrass, and mangroves, into further degradation, limiting further loss and damage, and contribute to the climate change mitigation efforts of the country. And then aside from that, of course, we also have programs still under the CMEMP and still within those marine protected areas, biodiversity friendly enterprises. And this is the social aspect of this program, as it provides supplemental livelihood or alternative livelihood to the communities who are putting more pressure as we see the depleting supply from our coastal resources. We are trying to add value from this raw resources from our coastal and marine habitat, therefore emphasizing quality over quantity. Also, that way we also reduce the pressure in our coastal and marine resources.
Okay. Mr. Avelino, I was wondering if you could comment. I'm sure you're aware that the incoming government, incoming administration had just listed down its budgetary priorities. I mean, and that includes climate change adaptation, renewable energy, so, and even agriculture and natural resources. So there's a few things there that's related to our topic. I mean, how does the, I guess, the community of practice on in the DNR, in the national government look at this development? If you want to comment.
Thank you, Dr. Tony. That we're very much eager, and we're very welcoming in terms of what our incoming administration has presented as part of his agenda moving forward. The CMEM particularly will be running until 2028. So we're expecting more effort or more resources to be allocated through the DNR and its programs, particularly on the blue economy, blue carbon, that will help us further alleviate or mitigate climate change. And even on climate change adaptation, we also see that as an opportunity for us to expand our programs and projects within the department.
Very good. Thank you, Seville. I just wanted to echo that, and not just for the Philippines, but I think, but for all the countries in the partnership and for all the region. It's something also actually that was stressed at the beginning by our chair, our partnership chair, in his own keynote, that in fact climate change is a whole of nation approach, and it's an ecosystem approach. It needs to be, in fact, incorporated into our our national budgets, into our development strategies, and this is the reason for this forum, because as we pointed out earlier, one of the purpose here is to be able to inform us better on how to develop the sustainable development strategy. I've had the pleasure of helping out in several iterations of the sustainable development strategy of the oceans of the seas of East Asia over the last 20 years, actually, with PEMC, and I'm very excited with this next phase. And I think a lot of things we heard here would actually be very good for that. I have an additional question from Professor Barker in the chat, in the question and answer chat. So if you can bring him back. You've said that there were many climate potential impacts, but they all relied on the same data input. So there's a question about how data is currently transmitted to those who need to use it to plan for impacts such as government and other stakeholders. Would you like to answer that, Professor Barker?
So I can't see. Could you just the question about data? What was the last part of that, please? Could you repeat that?
You said there were many climate potential impacts, but they all relied on the same data input, like rainfall levels.
Yeah.
So the question is, how is that data currently transmitted to those who need to use it so that they can plan properly for impacts, and such as government and other stakeholders?
Yeah, it's a very good question. I think that in terms of the regional data in this part of the world, the agency that, or the group that we're looking to coordinate through is Cordex. The previous generation of data, what was only made available to Singapore agencies for our own studies. But what we want to do now is to work. We're working with local universities, for example, who will be using, and maybe regional universities too. I think this is an ongoing discussion to make that data available. So that we can do research and to fundamental research, as well as using that in particular applications, to understand the impacts on dengue or on flooding, etc. So I guess the first thing to say is the raw data sets are huge. This has taken 2 or 3 years, take 2 years to produce all that data. So there's a bit of a technical issue about how we get all that data available. The project won't, the project I'm talking about, what we call the V3 project, won't actually be, won't complete till September 2023. And it's the #1 project at the national supercomputer in Singapore, and it's also taking a big chunk out of the Australian supercomputers as well. So there's a huge amount of data. So there's a technical challenge there using cloud-based systems or data toolboxes, and providing the analytical tools too. So, but we're currently working on agreements where we can make that data available to collaborators and others, but that is a work in progress. So we'll have more information on that in hopefully 3 to 6 months time. So if anybody's interested in that particular data set, then perhaps come back and send me an email in 3 to 6 months time, and we can provide more information, or we can. I would just add that of course we're not the only people in Southeast Asia doing this. The Cordex group is focused on regional climate projection data, led by Malaysia, Frederick Tanglin, and that's more atmospheric stuff. But I think in terms of the ocean stuff, which is what the interest really is here, I think it's also fair to say that I think, as I said earlier, the detailed ocean data, we just don't really have it yet. Because the current models are measuring sea level rise and the impacts, but in terms of the detailed circulation, salinity, temperature changes within the ocean, I think we're going to have to wait a little while for that kind of data.
Thank you, Professor Barker. There's a similar or related question for Dr. Kang on data. Dr. Kang, you highlighted international cooperation. So how can data and practices, data, I think, collection and dissemination be best shared internationally, including a region to inform policy planning, both domestic and international?
Well, so actually many ocean data shared by scientists internationally, I guess, and there are lots of data hub as well as some tools or methods to share the data itself. But I think the problem for the policymakers or general public to use this kind of data is very difficult, because they do not accustomed to the data format itself, and they don't know the exact variable names or how to handle those variables for their specific purpose. So I think the best way is to share the data and practices is to convey those data kind of a secondary processed data rather than the raw data just got from the in-situ in the ocean or the satellite derived data or model data as well. So those things, I mean that the people from the the middle school students to the some kind of the policymakers or general public, they can use some simple data to understand, and this kind of data can be shared by the lots of platforms, data platforms. I mean, so in Korea, I guess many people is working to make some kind of a database systems, but the database system is not so useful for the general public. So I guess we need some kind of some mediator or bridge between the general public to the specific science data. And if we can use that kinds of platform to hand over the science data to the publicly available data information, or some kinds of tools to handle that kinds of data, would be the best policy, I think.
Thank you, Dr. Kang. There's one final question for Professor Barker, which I can also actually ask anyone who wants to talk about green finance and climate finance, and how you're being able to position yourself. But how is Singapore faring? This is from Mr. James Martin Ambat. How is Singapore faring in terms of being a green finance hub in our region in Asia Pacific? Would you be able to answer that, Professor Barker?
Hello, I can try. I'm not a finance person myself. I'm a climate. I mean, in terms of what Singapore is doing, I mean, there are a few things, I guess. I mean, carbon tax trajectory to. I'm quoting some of the lines I've in the Singapore Green Plan, which includes a number of activities. But carbon tax trajectory to reach $50 a ton to $80 a ton by 2030. I don't know how that compares with others, but that's the level in Singapore's working towards. A few other things, I guess. Yeah. So there is let me just find the name for it. But yeah, there's the CDRIF facility. So in conjunction with Japan and the World Bank, Singapore is part of the Southeast Asia Disaster Risk Insurance Facility in Singapore to enable ASEAN countries to gain access to disaster risk financial solutions. So again, I'm not an expert on this stuff, but these are items that sort of related to the green financial hub. There is a green finance action plan, which again I don't have the details of, but includes a $1.8 billion US dollar allocation under Green Investments Program. So I guess that there's some of the things that I'm quoting. Again, this is not my field, but I'm sure if you have any more detailed questions, please you can send me an email and I can pass them on to the relevant people. Thank you.
Thank you, Professor Barker. Let me also share my own thoughts about climate finance. And link it to what we have been discussing. Right now, as I said, there's a meeting in Bonn, and climate finance is a very big thing in that meeting. Climate finance for adaptation, climate finance for mitigation, and very important, climate finance also for loss and damage. That's a third pillar now for climate finance. In the past, we've always framed climate responses as either mitigation or adaptation, both of which are long-term. In the meantime, many of our countries, the Philippines, for example, just went through two big climate events in the last 6 months. One was Odette, Typhoon Odette in December, and another one was Typhoon Agaton. Those are the Filipino names. So, sorry, I forgot the international names for both. Just this April and May, and they have been terrible in terms of loss and damage impacts, lives lost, and more importantly, well, not more importantly, but because the scale is so huge, we're kind of better now in terms of the Philippines is better now in terms of loss of life because we evacuate people, but still people died in both of these climate events. But the destruction has been widespread, pervasive. In the case of Odette, hitting like 4 or 5 islands, some of the biggest tourism hotspot, tourism hubs in the Philippines. So you can imagine the economic damage, the damage to agriculture that happened. So that's an area of climate finance that's now at the center of the climate negotiations. And I think there's a lot of things that we can do in the marine area, coastal and marine area, to develop programs, to develop approaches to loss and damage, distinct from what we have in the NDC, because the NDC, as we have seen in the presentations today, are mostly adaptation and mitigation, because that's still the old framework that we have without the third pillar on loss and damage. I'd encourage PEMC to also lead in that effort in developing the thinking around the third pillar, including it also in the Sustainable Development Strategy. For our final set of questions, which cannot be addressed to everyone, actually, there's a question about PEMC itself. What do we need to do in PEMC? What do we need to do in our in our partnership so we can help country partners pursue ocean-based adaptation, and as I said, also loss and damage solutions. Of course, more broadly as well, there are other international and regional organizations. I mean, World Fish, of course, the UNFCCC, Asian Development Bank, Asian Infrastructure Development Bank. What support can they give? I mean, any ideas on this would be good. And then there's another sort of big picture question I'd like to ask any one of our panelists, which is how about individuals? I mean, what's the role of individuals in addressing these challenges? So I open that floor actually to everyone in the panel for this, and also to our executive director, Amy Gonzalez, who might want to share some thoughts about the PEMC role and what she envisions the role would be. Thank you. Maybe Dr. Kang, we can hear from you again. The Philippines, we can hear from you. Unfortunately, we don't have our colleagues from Laos, Vietnam, and Cambodia that can answer this. I don't know if our colleagues from Korea would be one answer. I know they would answer questions also through the proceedings and by email. But if they'd like to answer to this as well, they can, of course, do that.
Yeah, let's see if the countries first want to speak or any in the
Please,
audience.
just raise your hand, please, and Secretariat, please prompt me if I need to call anyone.
Yeah, maybe I'll begin.
Okay, John, go ahead.
I may. Yeah, so we just want to reiterate with the ways forward as mentioned by Dr. Basug earlier. We see PEMC as a very important platform to really push for establishment of meaningful partnerships, effective follow-up and review, and inclusive sharing of experience across stakeholders and countries. And actually right now, aside from we are also, the Philippines is also part of the Coral Triangle Initiative on coral reefs, fisheries, and food security. And we're also at the process of developing its regional plan of action. So we see these regional platforms as a very important platform for us to really push for our agenda in terms of transboundary or cross country collaboration for the protection of our coastal and marine resources. Now, for the second question, in terms of individual, I'm sure our audiences have heard so many times different individual methodologies for us to contribute on this. Just a simple shutting off of electricity or appliances when not in use, and the use of renewable materials or reusable materials. Those are just some of the things that we can, small things, but actually add up to a greater or contribute to a greater effort, not just of their country, but globally to adapt and mitigate climate change. That's for us, Dr. Tony. Thank you.
Thank you, John. And may I suggest to the Secretariat, so we can be more flowing, we have a few more minutes anyway, if you can put up on the screen all of us that are in the panel, and so anyone can just raise their hand, and so it's more natural if you just, and anyone can just actually speak while while doing that, so at least whoever is here pa, so we can would you like to say something, Dale? Sorry, we're now on the last part, so I'm just gonna call you by your nicknames.
Okay.
But now I'm more familiar with all of you, so
That's okay.
So Dale, would you like to share something on this?
Yeah. In terms of PEMC and what international collaborations could do, I mentioned earlier, and from a climate science angle, our biggest ask in the region is data. and we can't do much science without data. And in particular, the ocean in particular is We've got a lot of observations from space, which you can see the surface, but what's happening under the surface, and we're not quite sure quite often in terms of currents and salinity and biogeochemistry and stuff. So I think there are maybe PEMC or other groups. So for example, the Global Ocean Observing System, the GOOSE. There is a sea goose, there is a Southeast Asia goose, and we're starting to have conversations about, actually sharing what's already there. And then the next part is filling in the gaps, the important gaps. And that gets more tricky because you then start talking about, if data sharing wasn't tricky enough, you then start getting into investments in new observation types. But I'd encourage people to look at some of the reports that are coming out, for example, of the World Bank in terms of the return on investment in observations in Southeast Asia. The factors are 10, 20 to 1. And Asia actually is the most, Southeast Asia is the most beneficial in the world. It's really, again, getting that green finance in the sense that investments for ocean observing systems is a big ask, but it's the big plea from the climate science community. On the individual, what can individuals do? I guess I can't add too much. I think, to me, it comes down to education. That's ourselves, it's each other, our governments, whatever it might be. Education is understanding the issues and having a clear sight of the issues. Education. Of course, the other one is, as we said, personal actions. They're the two comments I'd probably make there.
Thank you, Dale. Anyone? Dr. Liu, Dr. An, would you say something? Dr. Kang?
Yeah, well, I agree a lot of things. The Professor Barker told about the ocean data. Actually, getting ocean data is very difficult compared to the atmospheric data on the land. Or also, it is very difficult to get some data of the atmosphere from the ocean as well. So, just because it is very difficult to approach and as far as I know, in the meteorological community, they use some kind of highly well-designed global data networks, and they can use that kind of things, all the data from the land, oceans, and atmosphere as well. But the ocean data only Professor Barker mentioned that the GOOSE data or the best successful data, I guess, is the ARGO program, which makes about 4,000 vertical profilers getting around in the ocean, and they can observe temperature, salinity, as well as other in these cases, other biogeochemical sensors as well. Yeah, but that kind of the global data can be shared easily, but the problem is that the local or coastal data took by the each countries, that kind of data is very difficult to share, and I guess the PEMC could be encouraged to share that kinds of coastal data to share each member countries, and that would be better to use to make some kind of ocean-based solutions as well. So yeah, that's one thing I would like to add. And the other part for the the individual basis, and I agree also that education is very important, as well as still we don't know where matched with the ocean and the climate. And as I proposed in my keynote speech, then the still ocean and climate is a different words, but I would like to ask many people to understand and share the ideas of that the ocean climate, the marine environment, and marine ecosystems is kind of can be treated as a one, and we need to know more about that kind of things, how it changed and how it will go to change. So yeah. Yeah, that's my simple answer.
Thank you. Very good. Dr. Liu, would you like to say something?
Okay. Now, as I have said, the world World Wetland Film is prepared. Now have 5 teams to do the prepare working. I'm in the task team 5, the scientist panel. So now we collecting all the data shared in the world about the coastal wetland. Now we have a list about the linkage of about the database. So based on the database, we could evaluation the gap between the evaluating the status of the wetland about the world. We needed to based on this and to collecting more data, share more data, and to give a evaluated report about the world coastal wetland. Is our aim, our task team aim. I think it will be helpful for us to know more about the coastal wetland to concrete to improve the wetland to maintain to improve the maintenance to better cope with the challenge of the climate change. Okay. Okay, thank you.
Okay. Dr. Ann, would you like to say something? If not, yeah.
Okay. I really agree to all of you mentioned, with like sharing data about coastal things, and I really hope the PEMC have a role, and PEMC would be a platform to share the coastal information, because especially in East Asia, there are many different but similar specialties in coastal areas. And one more thing I would like to suggest that I hope PEMC encourages partnerships to co-work R&D or ITMO project for NDC, because all of you knows about the Paris agreements, and the implementation will be accelerated. So I hope PEMC will be the main body to encourage the ITMO partnership. Thank you.
Thank you. I don't see any more. Well, there's one question about Vietnam and plastics. We'll just send that to our colleagues in Vietnam, but I don't see any more questions in the question and answer. So I'd like to actually give Executive Director Amy the last word on this discussion. I would just say that while I agree that individuals are very important, and what we do, families, households, are very important, because climate change is in fact a global problem. You know, we really expect countries and governments and the big corporations, the big drivers of both climate impacts as well as potential solutions, to really step up to the plate and not kind of use not throw the bucket, throw the ball to individuals, say that's your problem and not our problem anymore. So I think in that context, I'll ask Executive Director Amy to share her your thoughts about the role of PEMC.
No, thank you, Tony. I think that you gave a very good message in terms of what individuals can do, but more importantly, the bigger players really who can leverage, and do more and have more impact to address the climate problems. Now, thank you for the recognition of PEMC as a platform for knowledge exchange, for facilitation of data or, putting people together. I mean, this is one of our activities really. Facilitation is one of our services where we try to surface and also at the same time come up with, get countries to talk about their programs and policies and also get our experts so that we can see how plans are informed by tools, practices and resources and vice versa. Because even from this morning's discussion, there seems to be challenges in how to make this more coherent and coordinated. So PEMC is at the moment preparing the 5-year strategy of 2023 to 2027. It's a regional strategy. It's called Sustainable Development Strategy for the Seas of East Asia. So one of the objectives of this forum really was to get information where we could help in the preparation of this regional strategy for this type of for climate change, which is a transboundary problem. Apart from this, one of the key services that PEMC provides is really the translation from science to policy and especially to local actions. And I emphasize local adaptation pathways. And at the moment, we have representatives from countries and research organizations and think tanks. But we would like to really trickle this information on the ground and how this information could be, as I think Dale's presentation said, how this could be stakeholder ready so that it could help inform when they refine their adaptation planning and also update their climate policies and their disaster risk reduction program. So we will have more of this, probably not just on climate change, but also other topics to promote the sustainable coastal and marine development. Every year, Ocean Roundtable Dialogue is actually takes place every year. We hope next year it will be in a face-to-face manner because it's quite challenging to have a dialogue, a real dialogue, just by looking at each other's faces on Zoom. So with this, I thank you, but don't forget that there's still an afternoon session where we have key experts also talking about tools, resources, mechanisms that we could avail of countries. I think Cambodia earlier, and it's unfortunate she's not here anymore. She also talked about needing technical assistance in terms of implementing their national determined contributions. I mean, these are the forum that we could have a good dialogue, actually frank dialogue, exchange information, get to know each other more, and then you have provided information on which networks, which organizations actually we could also tap and together build this platform of information exchange and knowledge management. Thank you very much. Over to Daisy.
Okay. All right. Thank you, Dr. Lavinia, and to all our speakers and Ms. Gonzalez for that very productive discussion. Before we conclude our morning session, may I invite our morning speakers and moderator for a group photo to commemorate this event. So may I call on our IT to take the group photo.
Okay, please turn on your videos and wear your big smile. And yeah, let's wait for the others. Okay, and 1, 2, 3, smile. Okay, and one more. Can we have one more? Okay, so 1, 2, 3, smile. Okay, thank you so much, all.
Okay, so thank you, everyone. And that concludes our morning session. Again, we will remind our participants to fill out the attendance sheet provided in the chat box. Do follow us on our social media platforms, also provided in the chat box, for similar events and updates on the work that we are doing for the Seas of East Asia. We will now be taking a 1-hour lunch break. So see you all after the break. So please be back at 1 p.m. Philippine Standard Time. Have a good lunch, everyone. Welcome back, everyone. Everyone had a refreshing lunch. We now begin with the afternoon session, focusing this time on the implementation of adaptation-based solutions for the coastal and marine sector. We will go over the region's progress and best practices in utilizing tools and systems to mitigate the risk and enhance coastal resilience in accordance with the morning's presentations. For this afternoon, we are pleased to have with us speakers from World Fish, the University of the Philippines Marine Science Institute, and the Institute of Global Environmental Strategies. Each speaker will be given 20 minutes. Before we move on to the presentations, may I invite our afternoon speakers and moderator for a group photo to commemorate this event. May I call on our OET to take the group photo.
Please turn on your camera and wear your big smile. And a count of 3. 1, 2, 3, smile. Okay. And may I ask for one more? Okay. 1, 2, 3, smile. Okay. Thank you so much.
Okay, thank you everyone. Starting off the afternoon presentations, we have with us Dr. Essam Yassin Mohamed, Interim Director General of World Fish, who will discuss the opportunities for climate change adaptation and mitigation in the fisheries sector, as well as how World Fish, as an international research institute, is supporting the governments in Asia in this regard. Dr. Essam, the floor is yours.
All right, thank you very much, Madam Chair. Let me quickly share my screen. Please do let me know if you're able to see my screen.
Yes, Dr. Essam, it's clear.
Excellent, excellent, good.
Thank you.
Well, thank you very much for having me in this very important event organized by PEMC and partners on this very auspicious and very important day that many of us can relate to, the World Oceans Day. Today in my presentation, I will try to cover a topic which is really important as well, which is how do we enable a shared prosperity for all through aquatic ecosystems under changing climate. Okay, so to begin with, what are aquatic foods, right? Aquatic foods are, aquatic animals and plants grown in or harvested in the wild from the water or food or feed, and they are synthetic substitutes. So the reason why it's so important to talk about aquatic foods more broadly than just fisheries is we're just trying to expand sort of in terms of the opportunity that arises from a sustainable aquatic resource management, which is not just the finfish, but also the shellfish, the aquatic plants, for instance, the seaweed and aquatic feed. There's a number of other aquatic foods that emerge from sustainable management of aquatic resources. And the reason why we talk about aquatic foods is that because they offer us multiple benefits from the provisioning services, such as, for instance, be it sort of a source of livelihood for billions of people, or as one of sort of the major sources of animal protein for millions of people, particularly in the developing world. But also in terms of its economic value as well, in terms of being one of the most traded food commodities, but also in terms of the employment and income opportunities, again, for hundreds of millions of people around the world, the majority of whom who live in the developing world. And talking about the developing world, of course, there are large-scale and small-scale aquatic reproduction systems, and the majority of people who work in the aquatic food system are primarily employed by the small-scale aquatic food production system. So the message I want to, for many of us, all of us, take today is that there's no such thing as small-scale. There are small but large section of our economies when you look at the significance of the supply of aquatic foods, where more than 50% is still supplied by small-scale actors, and that sector employs more than 90% of people who are involved in aquatic food production system, and also in terms of delivering the affordable and nutritious aquatic foods for millions of people around the world as well. However, despite the benefits of aquatic foods, climate change poses a significant threat to this very important sector, but also to the people who depend on them as well. So this is a recent study that colleagues from World Fish, including myself and other partners, did last year, looking at how climate change would impact aquatic food systems across the globe. And what it clearly shows us that, all aquatic food production systems in every country will be impacted by climate change unless we act now. And of all these countries, the countries which are primarily in the tropical regions, which is home to the majority of people living in poverty, are going to be hit hardest. And not only that, but also from an economic projection point of view, where profits are projected to plummet in low-income countries, as the diagrams show. So, for instance, if you look at the gray curve and the lower section of the diagram, that's the profit. And if you look at the comparison between the upper section, which is the high-income countries, and the lower section is the low-income countries, where the profits are all sort of projected to plummet under changing climate. Again, this is assuming we take no action today. That's a very important point to emphasize. Hence why I ask this very reasonably optimistic and positive question, which is, can we reverse the trend and realize a prosperous future for all? Because all the trends that I showed you are assuming no action is taken. But is it possible to reverse the trend? I personally do believe we have the opportunity to reverse the trend if we act quickly. And particularly talking about climate change, there are two sides to it, the mitigation side and the adaptation side, right? So if we focus for a moment, what are the mitigation opportunities from aquatic food systems? Aquatic food systems can enable us to pursue a low carbon pathway to meet growing demand for food. So because a number of scientific evidence demonstrate that aquatic food systems emit much lower greenhouse gas emissions relative to land-based food production systems. That's a fact. But also slightly outside the region, but I think so relevant, what we do in World Fish is we have this excellence in breeding when it comes to fish, and particularly with our tilapia fish, the genetically improved farm tilapia. And we have multiple generations of that. One of them is the 9th generation strain of tilapia in Egypt, for instance, which demonstrated up to 36% reduction in environmental impacts. That's including greenhouse gas emissions, partly due to best management practices that were introduced in aquaculture farms in the country. Therefore, yes, they emit much lower greenhouse gas emissions compared to land-based food production systems, but still there is a room for improvement still. And a good example is the 9th generation strain of tilapia, which demonstrates such a significant reduction in greenhouse gas emissions just simply by changing our management practices. But also there's another massive opportunity again to further reduce our carbon footprint in aquatic food systems. The use of low fuel gear can reduce greenhouse gas emissions in some fisheries by a staggering 61%, while reducing feed usage and switching to deforestation-free inputs can reduce emissions from aquaculture by, again, a staggering 50%. So the fact is that they are not only, the low carbon pathway of food production systems, the aquatic food systems, they still offer us a significant opportunity through some improvements to even reduce the carbon footprint further. Therefore, the opportunity is there. But I guess the most important point to realize here is, how do we transition to a low carbon food production system more equitably and sustainably, making sure no one is left behind? Because like any other transition, there will be losers and winners. And now the effort should be making sure that as we transition to the low carbon aquatic food production system development pathway, we have to make sure that no one is left behind, and we do that in a more just and equitable way. Another message again here is, yes, indeed, there is huge opportunity, but as the old saying in management goes, if you can't measure it, you can't improve it. And therefore, do we have the right tools in place to be able to measure and monitor our carbon footprint, or more broadly, our ecological footprint in our aquatic food production systems? And to fill this data gap in measurement, what we're doing at World Fish, working with partners, is we've developed a prototype of a digital tool that would help each and every farmer to measure their ecological footprint, and where the user interface also will have a advisory services, which can tell the farmer what sort of intervention would be required to further reduce the carbon footprint. And this could be extremely useful for farmers, which is the fish farmers, but also for natural resource managers as well, and for governments as well, as they want to see in terms of, the trend in carbon footprint of the aquatic food production system. That's that with mitigation. And now let's move forward with adaptation, or even better, I would rather use the word resilience, which I believe is slightly more transformative. Transformative in such a way that we're trying to realize a shared blue prosperity under changing climate through aquatic food systems. And to do this, in our analysis, we at least need 4 key ingredients or blocks, if you like. And one is reducing vulnerability by reducing risks and exposure to hazard is really key. If we're trying to build the resilience of aquatic food systems, we need to reduce vulnerabilities. At the same time, we need to enhance our ability to predict or anticipate climate hazard as well. Because a lot of loss is incurred, mainly because fish farmers, for instance, are not able or do not have the access or the means to anticipate climate patterns or weather patterns in the near future, for instance. And imagine if you had that capability, access to that capability. The third one is enhanced capacity to respond. It's not just being able to predict or anticipate climate hazard, but also how do we enhance people's abilities to be able to respond as well when that hazard arrives or comes as well. But also at the same time, I think it's really key that we explore the availability of viable livelihood opportunities through aquatic food systems as well. So let me share with you a few examples. One is as simple as examples from not far away from the region, but in Bangladesh, but also in Myanmar as well, which is part of the ASEAN, is investment in Hilsa fish restoration, where Hilsa fish is a common resource across the Bay of Bengal, which includes the West Bengal state of India, Bangladesh, but also Myanmar, which we believe is the same resource or fish stock there. And therefore, as the fish plummeted, what's been done is particularly in Bangladesh, where a significant amount of investment has been put into this through the government's hard-earned cash to restore the fish population over the past 10 or so years. And similarly, this has inspired action in Myanmar as where sort of, these are being explored or trialed in terms of, how do we incentivize fishers to sustainably manage the health of fishery in the country? And our economic analysis of such interventions demonstrate that the return on investment is about 9 to 11 times in Myanmar and Bangladesh, respectively, which is highly lucrative. But I also must add here, yes, indeed, by restoring the fish stock, we're building the resilience, but at the same time, the more fish we have in the water, the more greenhouse gas that we can sink or sequester as well. Fish have the same function as our forest in sinking CO2. A recent study found out that fish help us sink 1.6 billion tons of CO2 equivalent every year. So that means as we restore our fish, that means we're delivering more benefit for nature in terms of biodiversity, more benefit for people by creating income and employment opportunities, but also more opportunity for climate mitigation as well. So delivering a triple win for people, nature, and climate here. So that's a most cost-effective investment that we could do. And the other one is about, the second one I pointed out was about ability to anticipate hazard. And now what we've done is we've developed a digital tool again called Advisely, which is highly democratic in terms of its accessibility in terms of its user-friendly, where it delivers a new web-based interface for authentic, localized, timely, actionable, and simple climate information services. And what this has proven is that it can help fish farmers to be able to anticipate the damage that may occur as a result of climate change. And that means we will be able to abate the unnecessary cost on fish farmers and hopefully offer that prosperity opportunity for our fish farmers as well. And the other one is in terms of enhanced capacity to respond, again, for instance, again, in the Pacific region, where we have seen, analysis where when the sort of, natural disasters hit, how communities that practice sustainable management practices were found to be more resilient than those who do not. But also, I think in conjunction with the next point as well, is creating diverse livelihood opportunities, maybe through seaweed farming, for instance, which is sort of a growing industry now and is projected to grow at an annual rate of 10% until 2030. So how do we harness that opportunity as well to diversify the livelihoods of coastal communities in our region? And similarly in Southeast Asia, on the ASEAN region more broadly, particularly in Cambodia and Myanmar, where we have trialed trying to revive the traditional practice of rice and fish systems, where people can grow carbohydrate, which is rice, at the same time protein, which is fish, from the same plot of land using the same resource. So this means it not only offers the increase in income of up to 60% in our study that we found, but also it enhances water and land use efficiency, it reduces climate-induced risks, it's adaptable for diverse fish species, it helps rehabilitate degraded landscapes, but offers a viable livelihood opportunity under changing climate as well. So these are, as you can see, some new high-tech innovations. Others are management practices, and others are just revitalizing as simple as sort of indigenous and local management practices such as the rice fish systems. So it doesn't necessarily have to be sort of extremely high tech and huge investment that's required, but that's sort of a number of actionable and realistic, actionable interventions that we can take to enhance the mitigation opportunities for aquatic food systems, but also further strengthen the resilience and thereby realize a shared prosperity for all through aquatic food systems. Therefore, the message, I think, is only befitting that I send a very strong and positive message today, which is aquatic food systems offer us a sea of opportunities to turn the tide on climate change and realize a shared prosperity for all. However, before I conclude, I think we need to look at these from a systems level. Okay, when we talk about aquatic food systems, we cannot just talk about fish. We cannot just talk about fish farmers. We are talking about at a systems level, which are highly interconnected systems, be it the restoration of fish or market systems development, gender or social inclusion factors, availability of sustainable financing, be it through private financing or public financing through fiscal allocations or blending system, but also having a well-functioning governance system as well. So when we look at aquatic food systems, we cannot see things in isolation. We have to look at the entire system, whether we have functioning market systems, our governance structure, our social and economic inclusion, our sustainable financing, et cetera, that need to be looked at holistically in order to be able to deliver what we ought to deliver, which is a shared prosperity under changing climate. My conclusion is there are only 4 calls for action, in my opinion, here. Make sustainable, nature-positive aquatic foods as a key part of nationally determined contributions, because I think this is an opportunity, a missed opportunity here. If governments were to audit or make an inventory of how much fish they've got in their water bodies, and to be able to estimate how much those fish are helping us sink greenhouse gas, for instance, and imagine if that could be reported to demonstrate the country's effort in contribute towards the mitigation of CO2, for instance. And that would give us the impetus to invest even more in restoring our fish stocks or our fish population so that we can deliver on climate mitigation objectives. But similarly, we need to include aquatic food systems in their infrastructure, the workers, and the assets in national adaptation plans and disaster preparedness and relief strategies as well. So they become at the heart of these strategies. And the transition to a low carbon aquatic food based diets must ensure those who are furthest behind benefit most, and in line with the promise of the SDGs, ensuring no one is left behind. And finally, adaptation and mitigation efforts in and through aquatic food systems must be underpinned by, as I said, holistically, effective governance, predictable finance, social and economic inclusion, eliminating systemic barriers such as access to market and non-market services, and respecting ecological boundaries. If we deliver on these, we can deliver on a shared prosperity for all through aquatic food systems. And I couldn't think of any better way of delivering a positive and upbeat message on the World Oceans Day. And thank you very much.
Thank you, Dr. Esam, for expounding on the threats of climate change to aquatic food production and the mitigation and adaptation opportunities to respond to these threats, including examples in transitioning to a low-carbon pathway for equitable food production and ensuring food security. Our next speaker is Dr. Laura David, the director of the University of the Philippines Marine Science Institute, or UPMSI. UPMSI is one of PEMCI's regional centers of excellence, specializing on coral reef research and marine protected areas. Dr. David will be presenting the importance of an adaptation-driven, nationally determined contribution, increasing coastal resilience to blue carbon initiatives, and examples of tools and methodologies in support of blue carbon initiatives. Ladies and gentlemen, please welcome Dr. Laura David.
Hello, good afternoon to everyone. Can you hear me?
Yes, Dr. Lara.
Thank you for that introduction, Daisy. So let me share my screen. Can you see my screen now?
Yes, we can see it, Dr. Lara.
Okay. So this afternoon's talk actually naturally stems from the discussion this morning and the discussion of Dr. SM just now. And it's basically showing us a different perspective on in terms of our mitigation and adaptation. Okay. So I'll point out several factors here. So mitigating risk, enhancing coastal resilience, mobilizing investments, showing you some best practices, and then discussing a little on the tools that we can use. Okay, so basically every single drop counts. No? So this was there was a question earlier of how each individual can actually contribute to the reduction of CO2. Every single drop counts. So every single action that you make in order to lessen your carbon footprint is much appreciated. No? That's why even if the Philippines contributes only 0.39% in the global carbon story, and actually the ASEAN 10 contributes only 4.75%, no? Much less than our other countries all over the world, we still have to do our part in reducing our carbon emissions. No? So if you take a look at the table below, this is the most recent 2021 numbers. And as you can see, ASEAN 10 is producing much less than the EU 27, and definitely much less than USA and China, no? The two largest producing countries in the world. But we still have to do our part. That's why you have your nationally determined contributions. And we should be proud that all of the ASEAN 10 have already submitted or even updated their initial submission to the NDC agreement. No, the Philippines itself has committed to a reduction of a huge part, reduction of as much as 75% of our GHG by 2020 in the decade of 2020 to 2030. But the details of this, I think we have to further examine and maybe reimagine. Because it also just so happens that this western part of the Pacific is more exposed to climate change. So shown here is the latest trends in mean sea level. And all those that are red are either 7.5 to 10 millimeters per year. The global average is at 3.6. So everything you see in red is already twice to 3 times that of the global average. So as you can see, naturally, because of the huge Pacific Ocean and the circulation of the waters, a huge part of our side of the world, East Asia, will experience a lot of those increase. And since we do have a lot of low-lying coasts and a lot of cities or communities in low-lying coasts, there's a lot of exposure in terms of population. Aside from sea level rise, another common hazard for most countries here in East Asia and Southeast Asia in particular are the increasing intensity of storm events. No? So here is data set, just a chunk of the data set of typhoons, storm events coming in from the 1960s to the present. As you can see, there's a change in color, and the changes in color is actually showing that the intensity of each of those storm events is increasing from mostly tropical depression in the 60s. And then you have more and more severe tropical storm and typhoons in the 80s. And now you even have typhoons and extratropical cyclones. No? So it's becoming more intense. And these two are common for most countries in Southeast Asia and East Asia, and those have to be addressed. How do we adapt to those? So if we put those two together, our needs to contribute whatever we can, and also our need to adapt to this changing world, you really have to start thinking of the combined way of mitigating risk. No? So it's imperative that our NDCs are actually anchored on adaptation and resilience rather than just counting the greenhouse gas emissions and putting a tag on how much we will reduce. An example of this is when Haiyan struck Tacloban City. So you have the two pictures on the left, and you see here a satellite image of Tacloban City right before, a couple of days before Haiyan hit, and a couple of days after. And you see destruction, almost complete destruction of the area. But we also see that there are areas that fared better because of the significant coastal resource that they have. So here on the right is a picture taken of another city, a few kilometers northeast. And as you can see, the structures are actually more flimsy than that of the Tacloban City. There's just corrugated roof, low-lying infrastructure, and so on. So you would think that this would equally be erased, just so like what happened in Tacloban City. But what we see here is the 3.6 meter storm surge was actually buffered, because if you look at the top right part of that picture, that whole stretch is a mangrove, a thick mangrove forest, old growth. So because of that, the strength of the storm is attenuated. So this is a good example of how if letting nature-based solutions influence our adaptation going forward. So if you then take a look, so I'm using the Philippines as an example because I have the numbers for those. There is about 28% of the budget for the NDC is pointed towards either watershed management or forest protection. But out of that 28%, if you take a look, the mangrove rehabilitation is much lower. It's only than the rest of the contribution. So if you take a look at the protection of the upland, it's about 12 million, and then another 1.6 million in training people how to protect that, adaptation planning, vulnerability assessments, and so on. The mangrove rehabilitation is not even 10% of that. So I think that has to be reviewed in terms of the coupling of adaptation and our NDC. And that's just on the protection side, but it's also good to review that, because if you follow the science, you see that tropical forests do contribute a lot on carbon sequestration. And here in the graph, that's the last graph on the bottom. But actually, oceanic mangroves, salt marshes, and seagrass actually also contribute a lot. And that is not being appreciated enough. So you have several talks before that alluded to this, but I just wanted to show you, to emphasize further, that when we talk about sequestration in the marine environment, especially, we're not just talking about the above ground, which is what you see as living biomass, but you're talking about all those sequestered in the soil below those fauna. And in oceanic mangroves, estuarine mangroves, and salt marshes and seagrass, that's quite significant. In fact, oceanic mangroves is almost 5 times that in total carbon sequestration to tropical forests. So I think that should be further explored as the speaker before me said, that there are things that were missing on, no? Opportunities that were missing on. And I think this is one of those. So I'd just like to keep your attention on the mangroves and the seagrass. Because when we do mangrove reforestation, and mangrove forest protection, we not only address, this is looking at it as a system, as the speaker before me said, it's not just looking at just one thing. If you do mangrove protection, not only do you protect your coast from sea level rise and inundation due to the big storms, but you also do climate regulation of the sequestration. Plus, on top of that, you have all your fisheries that is associated with mangrove, either in the entirety of their life or in part as juveniles, or because it acts as a nursery ground. It also can be money-making area for the community if they do tourism of the mangrove areas. And it's a great water filtration so that further sediments and nutrients will not be able to go all the way to your seagrass and mangrove, because that's already filtered out in the to your seagrass and coral, because that's already filtered out by your mangrove. So it has a lot of services that it can provide to humans. Plus, finally, we do know a lot of studies that have shown that if all three habitats are in fact present in a certain area, not only do you have increase in biomass of the fish, but you actually have increase in biodiversity, making that area even more resilient. If you take away one of these, or if it's already lacking because of previous anthropogenic activities, then you've actually reduced the resilience of the entire system. So reversing this is possible. I'm hopeful, just like the speaker before me. Now, how do we do this? We know that resources are limited, especially in a lot of the tropical countries here in East Asia, but also in the rest of the world. What I'm suggesting is a way of carbon offsetting. So you have carbon being sequestered by both your mangrove and seagrass. And there's a lot of numbers out there. If you take a look at the literature, this is the average from all those that we've read, about 386 megagram per hectare for mangroves, and 108 megagram per hectare carbon for seagrass. So that's the average. But in reality, every single site is different because it depends on the species that are there. It depends on the soil that is there. It depends on the disturbance that has happened there, and so on. So, so if you do this on site, you should still measure. But I'm just giving you this number so that we can have a rough estimate of what this means. So I go back to the previous table, but now just highlighting the high carbon dioxide emissions of China, EU 27, and USA. And this, there's a way of carbon offsetting this. So why am I pointing to these countries? Because the Philippines and the rest of ASEAN 10 actually have very low carbon emissions. So we can easily balance our own, but maybe we can help in balancing the global CO2 and balancing actually specifically the carbon dioxide emissions of these countries. So what I'm pushing for is a co-investment with tropical countries of these three big ones. So it's not demanding that there be a compensation for the fact that we're the one that is taking the brunt of the climate change. It's more of a partnership of them being able to carbon offset what they're producing and us being able to do our adaptation with this mitigation partnership. Okay? So it's a win-win situation. So let's do numbers. So if I just do what is in the Philippines, right now we have about 0.3 million hectares of mangroves. And that's only 10% of what was originally there. So if you just plant enough to make it go back to what it originally was. So you're planting 2.7 million hectares, okay? What does that entail? What does that mean? It means that you're actually going to be able to store carbon, 1 billion megagrams of blue carbon. And if you convert that to CO2, the conversion factor is just 44 over 12 or 3.67. Then that translates to 3,824 million metric tons of CO2. And if you go back, so that's 3,824. If you go back to the previous slides, that's much more than the CO2 emission of EU27. So we can have a partnership with EU that we will plant here in the Philippines, what they can claim as their carbon offset. So I think it's a win-win situation. And that's just the Philippines. So if you go around all over the world, you'll see that there's a lot more that can be done. Now, I've been using mangroves as an example because that's easier, because people have a tendency to want to plant, want to do something active. So mangrove reforestation is an active way of sequestering carbon. But actually, if you take a look at all the sites all over the world, mangroves do contribute a lot. So this is a particular site that we went to. Mangroves do contribute a lot, but actually the seagrass contribution is also very significant, as well as the contribution of the soil that is next to these two habitats. No? There is also sequestration there. And what's the difference? The difference is you cannot, at the moment, very little is being done about planting seagrass, and actually a lot of seagrass scientists are opposed to that idea. But there is a way of protecting what is already there. Because if you don't protect this and instead you allow this to be decimated either by pulling it out actively or planting mangroves on top of it and so on, then you're actually allowing this stock carbon to be released. And that's devastating. Can you imagine how much that will release? So what I'm pointing out here is there needs to be, it's easy to incentivize people to plant because they can calculate how many trees they planted and how much carbon they actually help sequester. It's harder to incentivize people to protect what is already there and not allow the carbon that is sequestered to be released. And I think as a group, PEMC and all of its partners as a group can lobby about this and push for a way of putting credits to individuals, organizations, institutions, companies that will actually help protect what is already there so that it will no longer be released. It will continue to be sequestered. And seagrass, they do grow every year. So there's an additional about 0.2% increase every year of biomass. So you still continue to sequester. I think much more important is that you keep it there. Because if that's released, then that's a lot of carbon dioxide released to our atmosphere. So for best practices, I think that highly vulnerable countries such as ours, but are low emitting, can leverage opportunities to mitigate climate change impacts while significantly contributing to global efforts. So there are examples of this that have already transpired. There's a debt for nature swap that, for example, Brazil and the Amazon, they've done this. They've done it several iterations of actually reducing their global loans by protecting parts of the Amazon, because initially they said it's for the oxygen it produces, and then it's for the biodiversity that's there. I think next they'll do the carbon sequestration as well. So there are examples that have transpired in the last decades where a country was able to swap its debt by protecting something that is globally relevant. And then, if it's aside from that, you can also have just a country bilateral country or regional cooperation that pushes for the adaptation mitigation partnership. So countries that would like to be able to offset their carbon can invest in the adaptation, in the protection, and actually in terms of mangrove, also actively growing more mangroves, and that will protect the countries that have them, but that will also carbon offset those that need carbon offsetting. So this can actually be further investigated, and maybe we can come up with several pilot engagements so that others can follow. Now, in terms of where this will work, so you see here the global distribution of mangroves and global distribution of seagrass, and as you can see, a lot of the tropical countries, you can actually engage with the prospect of protecting and even planting new mangroves. For the seagrass, there's also a significant amount, especially here in our region of the world, where you can have huge areas where you can protect your seagrass species as well. So finally, I just wanted to point out some tools, because all of this can happen, but you still need a way of prioritizing, because there are areas that are more susceptible to the impacts of climate change, because of not just because of their physical attributes, but also because of their social and economic attributes. And you have to study this site by site. So for the Philippines, we've done assessment of climate hazards using just remote sensing in the last 3 decades, and showing areas where the trends look like they're more prone to certain things like temperature increase, changes in rainfall, and sea level rise. So sea level rise, it turns out the entire Philippines is quite vulnerable to sea level rise, with 2 to 3 times the global rate. In some areas that are low-lying, highlighted here at the right. So climatecentral.org shows you these projections, and you can choose the one for each height of the land, for each topography. And you can see, for example, in the Philippines, which areas will most likely suffer from coastal inundation. So that's either sea level rise or inundation due to storm events. And once you have that, you can then look at, if you have target stakeholders. If you have, for our part, we wanted to see how many of the fisher folks actually live within those areas that we identified to be very vulnerable to coastal inundation. So we have the number of fisher folk per area, and those that have high number of fisher folk and at the same time high flooding event, then we tag those as being the vulnerable communities. So if we have resources, we would pour those onto this specific communities first before we do it in other areas. And there are more and more science that is coming out that gives you, simulations, predictions, because if you take a look at the global predictions, the resolution of that is not enough to do decision making on the ground at the level of the communities. So there are more and more science coming out on specific hazards. So in this case, storm surge heights, in which areas will most likely suffer from how high of a storm surge. So we also took a look at this study and overlaid that on the previous study that we made, and highlighted areas where it showed up in both studies. And So that gives us a way to prioritize. And I think that that exercise should be done by each of the countries as well. And then finally, final slide, as emphasized by the previous speaker, you have to look at this in a holistic way, no? And so I can't just focus myself on mangroves and that's it, because although that is already servicing a lot of what is needed in terms of adaptation and mitigation, it cannot stand by itself. You have to take a look at the land, reach to reef, the land change, the sea changes. Are there any nearby direct exploitation like coastal mining that will actually affect that, or reclamation? And then are there pollutions that will actually eventually undermine my management interventions and so on, no? So, but if we approach this in a system scale and we take a look at this holistically, then we will be able to address those that have driven our decline in our nature, no? So summarized on the right are examples of declines in nature. And I think I am hopeful, just like the previous speaker, that this is reversible. A lot of this is reversible if we act now. That's it. Thank you very much.
Thank you, Dr. David, for sharing with us some examples of tools, methodologies, and studies, such as the carbon sequestration contribution of our different marine habitats, the carbon offset method to mobilize investments, as well as best practices and use of data and climate science in advancing adaptation measures to mitigate risk and enhance coastal resilience. Our third and final speaker for this afternoon is Mr. Osamu Mizuno, Program Director of the Adaptation and Water Area of the Institute for Global Environmental Strategies, or IGES. He will share with us the functionalities of the Asia-Pacific Climate Change Adaptation Information Platform, or APPLAT, which was established at the G20 Summit in Japan in 2018, with the vision of helping Asia-Pacific countries to build a climate resilient and sustainable society. IGES is also one of PEMC's regional centers of excellence, focusing on climate change adaptation and disaster risk reduction. Ladies and gentlemen, please welcome Mr. Mizuno.
Thank you very much for your kind introduction. Let me share my screen first. Okay, I hope you can see my screen, right?
Yeah, it's clear,
okay,
Mr. Mizuno.
Okay, thank you once again for giving me a very important opportunity to introduce APPLAT at this very important meeting. So let me start my presentation by briefly introducing my organization, IGES. IGES is a policy research think tank based in Japan. We work on various research projects under the mission to achieve sustainable development in the Asia-Pacific region. And we, as introduced, we become the regional center of excellence in climate change adaptation and disaster risk reduction of PEMC in 2020. From then on, we have been closely collaborating with PEMC and its partners. Today, I would like to introduce Asia-Pacific Climate Change Adaptation Information Platform, or APPLAT in short, as our key activity for facilitating regional collaboration on climate change adaptation, as it could have the potential to contribute to the regional efforts on the nexus between ocean and the climate change. So APPLAT was established by Japanese government in 2018. It's intended to serve as a platform to facilitate the collaboration among the partners and partner countries in this region for adaptation. And APPLAT has three pillars, as you can see on this screen, on tools, scientific information, and capacity development. IGES is a delivering partner to connect scientific knowledge with adaptation planning and project formulation through leading the efforts on capacity development program of APPLAT. While the capacity development program of AP-PLAT is still in the initial stage, AP-PLAT already has its dedicated website as shown in this slide and provided various information and tools. And I want to introduce some of the tools and information provided through this AP-PLAT webpage in the following slides. One of the tools available at AP-PLAT is ClimateCast. ClimateCast is a climate projection tool that shows climate projections up to the year 2100 with 10 major climate simulation models in 4 representative emission scenarios. The tool covers all the countries in the world and allows users to compare different scenarios and models, as well as downscale the results to sub-regional level. And to get to know how to use ClimateCast, the e-learning course is available. And now I want to show you the brief video of the introductory module of this ClimateCast. It is just 3 minutes long, so please have a look at it.
Mr. Mizono, we don't have the audio for the video.
Really?
Yes.
How can I do that? Oh,
Please click the share sound.
share sound. Okay, wait a second. Oh my God. Share sound.
Can you please share it again and click the share
Screen?
sound under? Yes.
Share sound. Okay, okay,
Yes.
okay, okay. This right? Oh, it needs password to enter the Zoom. What is this?
Hello, everyone. I am Yuji Masutomi at the Center for Climate Change Adaptation of the National Institute for Environment Studies. I am the head of the Asia-Pacific Climate Change Adaptation Research Section. Today, I am here to introduce you to a software tool I developed called ClimateCast. Simply put, ClimateCast is a tool to provide everyone out there with easy access to the latest climate forecast information. The name of the tool ClimateCast consists of 2 words, climo, a prefix to indicate climate, and cast, which means looking into the future, or turning your eyes on something, as used in forecast. I combined these 2 words, climo and cast, to come up with the name ClimateCast for this software tool I developed. Now I will explain how ClimateCast works. First of all, here is how you find ClimateCast. Let me show you. What you see here on the screen is the front page of the AP-PLAT website. On top of the page, you see these images which we call animated MV. Among them, you see this image of the Blue Earth caption, ClimateCast was released. Click on this Go to ClimateCast tab here, which will take you directly to the ClimateCast interface. What you see here on screen is the front page of ClimateCast. ClimateCast works basically in 2 different modes. One is the map mode, and the other is the chart mode. What you see on the screen right now is the map mode. Each nation on the map is colored separately. The colors reflect the levels of the temperature rise in each nation, nation by nation, you see. So, by looking at the color difference, you can compare the levels of temperature rise in different nations. The chart mode, on the other hand, looks like this. The chart shows the temperature rise from the 1980s, late 20th century, to 2090s, the end of the 21st century. The chart mode can tell you exactly how the temperature rise happens.
Mr. Misuno, you're on mute.
Okay, okay.
There you go.
Sorry.
Thank you.
Yeah, okay. Then, okay. And sorry for the trouble. And another downscaling tool available in the AP-Plat is Climate Impact Viewer. A Climate Impact Viewer shows the results of a climate change impact assessment. There are several available simulations of future climate impacts, such as sea level rise and its impact on crops. They provide scenario-based predictions up to 2100. AP-Plat is also providing useful content for capacity development. One example is an e-learning course on building resilience to compound and cascading disaster risks. This course provides tips for strengthening resilience to the increasingly complex risks associated with the climate change and other hazards like COVID-19, with several case studies. As climate change impacts are context and location specific, we have plans to produce dedicated guidebooks in local languages to meet the specific local needs based on the findings of this e-learning course. This year, we plan to conduct a pilot project on coastal disaster risk reduction in Bangladesh. Another example is an e-learning course and website on nature-based solutions. The e-learning course provides basic concept of NBS and how to practically use it as a solution to climate change. The website, inspired by Nature-Based Actions and Solutions, or INAS, showcases good practices of NBS around the world. There are several more e-learning courses available on this AP-Plat webpage. So please visit AP-Plat and click Literacy tab for further information. Another effort under AP-Plat I want to introduce here is a new IGES APN joint project on locally led adaptation. APN, or Asia Pacific Network for Global Change Research, is an intergovernmental network of 22 countries that is successfully addressing the challenges of global change and sustainability through providing funds to the critical projects in the region. This new IGES APN project is provided fund from APN and aims to catalyze local adaptation innovation and the localization of NDCs through a regional partnership among knowledge institutes in the region through making the best use of indigenous and local knowledge. This project mainly focuses on capacity building in 4 important areas, as you can see on the screen, and establishes case study sites in the Pacific, South Asia, and Southeast Asia, namely Samoa, Nepal, Bangladesh, Vietnam, and the Philippines. As such, AP-Plat is also working on the ground in Asia with the partners, in addition to providing information tools through the dedicated webpage. Now, let me summarize the overall potential of AP Platt in the context of ocean and climate change nexus. In our view, AP Platt could be potentially utilized in 3 ways. The first role of AP Platt could be to catalyze science and policy interactions and integration. Through providing information of localized climate impacts, for example, AP Platt informs decision-making processes toward sustainable and resilient society at the coastal community level. The second possible function is knowledge sharing. AP Platt can serve as a knowledge tank where the past experience and good practices inform policymakers around the Asia Pacific. Lastly, AP Platt aims to accelerate efforts to enhance capacity of national and local governments in the region for adaptation actions. Capacity development activities focusing on ocean and coastal areas could be featured as a key theme in the coming years. And IGES is intended to take the lead of this capacity development program and facilitate the partnership and the collaboration among the key institutions and the national and local governments in the region. Now, with these efforts under the AP Platt as its background, IGES has become the PEMC Regional Center of Excellence in Climate Change Adaptation and Disaster Risk Reduction in 2020, as I explained in the beginning. Since then, IGES have been working with PEMC to pave the way for making valuable contributions to the region and the nexus between the ocean and climate change. In this context, IGES and PEMC Resource Facility conducted a pilot project collaborating with Guimaras Province, the Philippines, to facilitate local adaptation planning by utilizing the fund provided by Adaptation Research Alliance, or ARA, led by the United Kingdom under the presidency of COP26. We carried out a workshop to explore long-term adaptation planning based on local adaptation knowledge. As a next step, we plan to sophisticate the local adaptation pathway by utilizing scientific tools provided by AP Platt. Finally, I just want to briefly touch upon the EAS Congress held last year. We will further promote this kind of collaborative efforts between PEMC and IGES in the future. And I would like to mention the session held last year at the EAS Congress. IGES, as a PEMC Regional Center of Excellence, organized the session titled Making Asia Pacific Resilient to Climate Change, where the fruitful discussion regarding how we can create synergies through the partnership between AP Platt and PEMC. IGES will continue to explore the potential collaboration with PEMC partners to activate science policy integration in coastal communities. With that, that's the end of my presentation. Thank you very much for your attention.
Thank you, Mr. Misono. We welcome IGES activities such as the application of the AP Platt in developing scientific knowledge and information related to climate change impacts in the region, providing support tools for stakeholders engaged in policymaking, and providing capacity building on climate change impact assessment and formulation of adaptation projects. We now proceed to the open forum for our afternoon session. Ladies and gentlemen, let us welcome Ms. Amy Gonzalez, the Executive Director of PEMC, to moderate this afternoon session. Ms. Gonzalez, the floor is yours.
Thank you, DC. Can we also call, bring up the Zoom of all the experts? I think it would be good to have them all so that we can have a dialogue and just make it a very friendly and informal, happy World Ocean Day to everyone. Thank you for the excellent presentations from our three speakers. I think your presentations actually could be the beginning of a blueprint, that could help refine countries' climate change adaptation and mitigation, disaster risk reduction programs, as well as a regional package of all issues, ideas, and options. You know, there's so many practical tools, resources, and systems that we could work together. And they are not rocket science. They're actually very practical tools, you know, from the aquatic systems, from what Laura has mentioned also on blue carbon storage and marine ecosystems resilience and capacity development, you know, pushing science policy interface that Ms. Ono-san also mentioned. Really lots of tools that are at our disposal. But to begin the discussion, I'm going to ask a generic question to all of you. But what's the problem? I mean, we have all these tools, we have resources, we have mechanism, but why isn't it reaching where it should matter? Our local communities, our coastal communities, the fisher folks. Where is the disconnect somehow? And I don't want you to say, I don't want a response to say, you know, it's finance. You know, can we be more creative in our response? I mean, from where you sit, where do you see are the shortcomings, and how can we actually compensate or overcome or work on this in your organization or together as in the region, basically as regional organizations? Thank you. Who would like to begin? Okay, Assam?
Sure. I would have prepared to go last, but anyway, let me, someone else come forward. I think it's a very important question indeed. I don't think there was a shortage of tools. I think today was a good example of that, number of tools out there. But I think it's also a part of human behavior or nature to ask oneself, what's in it for me? Right? So I think as part of democratizing digital tools, for instance, if they are designed from the perspective of a scientist, right? So that it advances science, so that, you know, we can collect more data, so, you know, we can do more analysis. That's one perspective, one worldview. But I think the end users, let's say in this case, for example, the fish farmers or coastal communities, the first and fundamental question is, what's in it for me? There are a number of digital tools that we use nowadays. If you go to rural areas in Cambodia or Bangladesh, for instance, a lot of people use different social media platforms or mobile phones, etc. It's not about the lack of access to technology per se. I think one of the critical aspects is that, are we designing something fit for purpose and that can demonstrate real value to end users? I think that's a demand side. So if we're tackling the supply side only, and we flood communities with a number of digital tools to use, but without necessarily understanding or demonstrating the value of using that, right? So I think where effort is needed from the expert side, to be honest with you, is to assess the demand and create the demand or demonstrate the value of such digital tools. For instance, digital tools that are utilized to be able to enable people to predict potential climate risk or hazard. For instance, you know, being able to demonstrate that through extension workers. And we're doing that in Bangladesh, for instance, where we were able to reach 100,000 fish farmers by mobilizing around 100 extension workers only. You know, just these are given the mandate to actively engage with the fish farmers and demonstrate the value, how the information service works, how the advisory service works. But it shouldn't stop there. I think it's about the continuity until people are able to see the value and then become the owners of such tools. Therefore, I think as experts, we have the responsibility, not just to think from that expert's perspective, but to be able to answer the question, what's in it for me, that comes from the end users.
So incentives is key. Laura,
Correct.
any additional thoughts?
Yeah, we can spend a whole night discussing this, I think. But I agree with Dr. Esam's point. But I think I want to highlight three things. First, I think we need to be able to give power to the communities. So there has to be a national decision of prioritizing adaptation mitigation activities over any other development that needs to be pushed for the communities. Because without that, whatever the community does, if they are superseded with the need for the national country to build roads, for example, it will not come to anything. So there has to be support from the national saying that if you identify areas that need protection and that we will try and find money for you, but you need to do the legwork, you need to do the hard work on the ground. That is important. But on the second point, I agree with Dr. Esam. A lot, we've been trying to do this. We've had so many manuals on how to evaluate and monitor your coastal resources. And we've been scratching our heads on why is it still on the shelf and not being used on the ground all the time. And we've hired science communicators and they've taught us a lot on what can be absorbed and be useful from the standpoint of a fisherman, from the standpoint of what we call Bantay Dagat, or the volunteers who actually guard the coast and so on. So as scientists, it was really hard to keep the science there, but put it in a different perspective so that it's more driven by what Dr. Esam is saying, the need of the community rather than the need of the scientists to get more data. Okay. And then lastly, I saw it in chat. We need to actually engage the local elementary and high school teachers because they're the permanent fixture in the coastal communities. The leadership may change, but the teachers usually stay there for decades. And if we engage them, if we give them this information in a way to include that in the curriculum, to infuse the curriculum with this science and make it useful for the community, I think that will have repercussions, positive repercussions that will be sustainable.
Thank you, Laura. Mizuno-san?
Yes, thank you. Let me point out two things. First, that as you explained, that it is true that there are so many tools available in this region and beyond, and that there are lots of information, scientific information produced every day and every minute even. But I think to translate this reality into action, first of all, everybody have to understand the real threat, risk of climate change and the needs of adaptation and mitigation actions on the ground. I think especially the local level, it's that acknowledgement, this threat is not, I don't think that it's high enough. I can see that kind of a lack of understanding everywhere, including my country. So we should not underestimate the importance of raising awareness of taking actions on mitigation and adaptation in this at the local level. That is first point. The second point is that there are so many, as I said, so many tools and so many interests and so many stakeholders in the community, but tend to be working in isolation and not necessarily systematized. So we need some glue or some coordination mechanism or some implementation framework to make work in harmony and move into the same direction to make the individual power in one big power. So I think that some kind of implementation mechanism, including legal framework or even a practical plan or anything is fine. But at least we need some systematic platform where everybody can work together That's I stop here. Thank you.
Yeah, thank you. Very interesting perspectives Sean shared, and also some additional inputs which actually interlink with one another, from awareness raising, education, teachers are key, providing incentives, looking at the demand side, not just the supply side, and really working with communities on what they are on their needs, right? But it's a what you call it, virtual cycle where they don't know what they want until you also point it out to them. So there is this term coined by the UN Decade of Ocean Science about co-designing at the local level, co-management. I think co-management is an old term already, but I think co-designing, even research, they said would be a good way to go about it. And yeah, so our challenge really is, replicating and scaling up many of those best practices and models that we have, and also takers, for example, on these integrated aquatic systems, on what Laura also mentioned as integrated marine resilience or blue carbon storage systems, and what IGAS is trying to promote on local coastal adaptation pathways. So it would be good at some point to come together again to see whether we've made some progress from this, and whether, it's not just HILSA who's doing it's not just Bangladesh who's doing HILSA and Myanmar, but more countries are adopting it. I think we have some questions also from the floor. There is a technical question here, I think from this morning. There's an interest to learn on carbon sequestration computation for marine conservation. How do you, there's some typo here. How do you, I think, undertake baseline GHG emission and compute contribution of mangrove protection of coastal resource management in general? I think they want just like an overview of how it is done in mangrove protection. Probably Laura, you can start on this.
Yeah, you basically have to do a mangrove assessment. So you go through the mangrove and do your measurement of above ground biomass. No? So the girth of the tree, the height of the canopy, and there's you can use globally available constants, quote unquote constants, and at least have a first-hand measurement of that. But what I've shown earlier is that's not all that there is in terms of carbon sequestration for both carbon and seagrass. So you do have to have a lot of below ground measurements. And for that, you have to do coring. So you do cores, about 1 meter of core in the mangrove areas. And you have to go to the laboratory and basically measure that amount of carbon that is there. Again, there are papers that give you numbers that you can use as a first estimate, but we've really seen a huge range of numbers depending on the site. So you do the same for the seagrass. You can calculate the density of a certain square meter and then extrapolate on that for the rest of the area. You can do that just by swimming and measuring the area itself, or by using remote sensing and doing it there. But then again, for the below ground, then you have to still also do coring on that area. Not necessarily a whole meter for the seagrass, maybe even half a meter or partial of that will suffice. But there's no shortcut to it. You have to do the field work and the lab measurements.
I see. Okay, thank you. We would love to get copies of papers that you could recommend to the use that we could share also, Laura, if you can.
Yes.
After this workshop, this webinar.
Yes,
Question for Dr. Yeah, thank you. A question for Dr. Essam. How do we effectively couple a shift to lower carbon aquatic foods with managing the current global crisis in fish stock sustainability? I think this is on the marine, the wild catch, right? So the balance.
No, I think that's a very good and very fundamental question. The person who was asking this question, I think they are absolutely right in pointing out that our fish resources in general are in crisis without an exaggeration, where sort of 1 in 3 are sort of depleted or overexploited. So there is definitely that. But I guess the question is, what is driving that? Okay. One of them, sort of the big whale in the room for us is on fish subsidies or fishery subsidies, for instance, or capacity enhancing fishery subsidies. As we know, next week the WTO is, for instance, calling for interministerial meeting, and one of the issues that ought to be discussed and hopefully finalized is to reach an agreement on ending harmful subsidies. Harmful subsidies essentially meaning subsidies given to fishing vessels or fleets to essentially artificially deflate the cost and make their fishing activities profitable, so they can go hundreds of thousands of miles away from the coast and still being able to fish, and that still becomes a profitable activity. This doesn't help. And of course, some may argue that this is given under the pretext of poverty alleviation. But if you look at the statistics, 86% of the global fisheries now is given to industrial or big fleets. Only 14% according to the latest estimate, is given to small-scale operators. So I don't believe that fishing subsidies are being provided to fight poverty at all. What they are doing is essentially they are capacity enhancing, but a significant part of that is capacity enhancing subsidy that's enabling these fishing vessels to hoover up the ocean, without which none of these activities would have been profitable. And therefore, I think one of the low-hanging fruits for us is, if we were to restore our fish stocks, we need to eliminate harmful subsidies, as from a practical point of view. The second one is sort of the link between addressing the crisis, but also putting our food system on a low emission pathway. Again, another hidden agenda or hidden element here is the issue of food loss and waste. The paradox: we live in a world of plenty. We waste more than a third of the fish that we catch. And that's maybe mishandling or lack of access to services, or maybe sort of lavish lifestyle in some parts of the world. And therefore, imagine all that amount of effort, including CO2 emissions, but also the food security and nutrition security opportunity that's lost in vain, because we waste a third of our catch. And imagine if we were to address that bit as well, if we were to significantly reduce and where possible eliminate food loss and waste, so we can meet the food and nutritional security for millions of people around the world without necessarily excessively sort of harvesting fish out of the sea. So my point being here, I think there is an action that we can take to curtail the capacity enhancing fish subsidies that would address quite a significant chunk of the problem. By the way, you ought to meet that target 14.6 of the SDGs by 2020, and we're now in 2022, and we're still talking about that. Therefore, I think we have the mandate as global citizens collectively to act together to end harmful fish subsidies and address this big threat to fisheries. And the second one is, again, achievable, is we need to have to collective effort to make sure food loss and waste, which is more than a third of fish caught today, is that sort of loss and waste is eliminated, either through giving people the access to services, or by maybe disincentivizing consumers as well, sort of from wasting these hard-earned resources as well.
Okay, lots of food for thought there, from food loss and waste to eliminating capacity enhancing subsidies. Are you advocating for the shift of the subsidies to promote lower carbon aquatic food systems?
Excellent, excellent. So I'm a former bureaucrat myself, Amy, and I'm so glad you mentioned that. When the moment you say eliminate subsidies is not politically palatable, and I completely understand that. And therefore, the narrative should be, because we need to deliver a net political gain here as well. So the narrative should be, we need to make a transition from a bad subsidy to good subsidies. Okay, if governments wish or authorities wish to provide subsidies, they can continue to do so. But what we are asking for is a transition from the bad, which is capacity enhancing subsidy, towards more good subsidy. Therefore, I think good subsidies can be provided as incentive packages, for instance, for fishing vessels that are introducing sustainable practices, for instance, or fishing companies that are investing in sustainable R&D, for instance, and or communities like in places like Bangladesh, for instance, where they are bearing the cost of the short-term cost of sustainable management of fisheries, and where the governments are subsidizing these communities to incentivize them to continue sustainably manage their fisheries. So there are multiple ways of offering good subsidies, but it's about being wise in a way that we use those subsidies to incentivize good behavior and disincentivize bad practices.
Yeah, good behavior being it should also not promote fuel harmful subsidies.
Certainly.
Yeah, okay, thank you. There is a question here from Jorgen Lawrence, which I don't quite understand. Won't be a key to securing coastal ocean protection efforts to finance and secure livelihood for the coastal people, fishermen. I'm not sure if there's a missing thing here. I don't really get it. If Jorgen is there, do you wish to take the floor to ask your question, but very briefly? I don't know if
Can you hear me now?
Okay.
Hi, Amy. No, I think main reason from the coastal side is also overfishing, depleting actually of fish stock, and to build up this fish stock needs time. So we have to break this vicious cycle, and it can only be broken if we support fishermen and finance fishermen throughout this period to also employ the fishermen to build up this fish stock and then use them in a sustainable way. So we have to bridge this time, which is to cover a fish stock needs 5, 6, 7 years even. And in that time, you have to really support these fishermen, which live really from hand to mouth. And if they're not supported, they really engage in these destructive fishing practices at the coastal areas. So that was my question, background.
Okay, so it wasn't a question, it was a comment then. Thank you, Lord Jorgen.
It's also a question. It's also a question. I want to get a feedback. How do you see that from your side, from the science side? Is that a way? And we really believe that this is an essential point to really break that ice there and really support these fishermen. And we see in the past money which is spent in the countries is not reaching the fisher folk. It's trickling down, but it doesn't reach the people who are really at the front line.
Okay, I'm just conscious of the time, Jorgen, and the topic is veering away from the ocean climate nexus. And so I will continue to read the questions and get the speakers to respond to those questions directly addressing the topic for this afternoon. But I would encourage, I think, Essam and Jorgen, if you can, Essam, if you can answer Jorgen, perhaps on the Q&A. Is that okay?
Yes, it's fine.
Yeah, thank you. So, Dr. David, adaptation to climate change is linked to local, economic, environmental, and political stresses, social vulnerabilities, and varying adaptive capacities of each country in the East Asian Seas region. So I think the question is on the future direction of seagrass restoration at the regional level? Is it making progress overall? And I think it's still at the nascent stage, no? And where might it have the most impact? Probably you can just elaborate on your presentation on seagrass.
Yes, in general, seagrass restoration is at its very infancy. No, there are very few papers that actually have tried seagrass restoration. So we're actually pushing more for existing seagrass meadow protection instead. And the way to do that is to addressing what Dr. Essam also suggested, is to show the community that having a thriving seagrass meadow is actually good for them in terms of fisheries, in terms of biodiversity resiliency, and so on. And just showing them also, oh, and by the way, if you protect this, you also contribute to lessening the potential for more drastic climate change. So something like that. And that story needs to be told, I think, over and over again. But where that is most applicable, so if you take a look at the seagrass distribution globally, it is in this region, our region. No? So it's the Southeast Asian region that has the highest extensive and high diversity of seagrass. So it's here that we can make a difference.
Okay, thank you for that, Laura. We could have even a session just on seagrass also. It's a fascinating topic. Now, there's a question from Misuno-san. It says here, IGS organized a session on AP Plot at last year's East Asian Seas Congress, searching for synergies. PEMC has piloted this at the Guimaras in the Philippines. I think applying the tools of IGS within an integrated coastal management program. So could you see AP Plot and guidemate adaptation as fitting within holistic local level strategies? How would local governments deal with a lack of data at smaller scale? So I think this refers to lessons from the pilot adaptation model you had presented at Guimaras, the IGS, within the ICM framework. And then, so the lack of data. Smaller scale.
Okay, then maybe the 2 points now. The lesson learned from the Guimaras, the pilot program. I think that it was a very good experience for us to work with Guimaras province and PEMC, and their experience in ICM implementation was a great help in introducing especially the co-production processes. We observed that ICM promotes multi-sectoral engagement with multi-level integration and coordination, and therefore every sector has a responsibility. And the participants to the workshop of this project share the views that the ICM experience has provided a venue for multi-stakeholders consultation in the addressing priority concerns, including climate change. Therefore, based on this experience, we explore the possibility to replicate this good exercise to other sites or the countries, and scaling up this into a real project, because of we conducted this project utilizing ARA microgrant, which we believe intended to be scaled up by UK government. No official commitment was made by UK, but we are expecting something can happen for the next step for this. So that is first thing. The second thing, the lack of the information. I quite agree that the information is still, generally speaking, especially the climate change impact information is country or global or regional scale. So it's not detailed enough to fit into the needs of the community level. That's why we try to promote the develop downscaling models for analyzing the potential implication of climate change to the local level. So we continue this effort. That is first thing. But at the same time, we shouldn't just wait and see until that the downscale model will develop. And there are so many, actually, there are so many closely related areas between climate change adaptation and general sustainable development efforts. Therefore, there are, in other words, there are so many win-win opportunities exist. So even without data, there are so many no-regret options actually available. And now NBS, nature-based solutions, emerged one of the possible potential no-regret options to which could contribute to the climate change adaptation as well. Therefore, that is one approach to try to see the possibility to apply the nature-based solution. That's one thing. Another thing is, for example, early warning system is very considered very relatively cheap and significant potential to save the human lives and even the potential assets of the society. That kind of thing is can be considered to be introduced even without the details downscale analysis. So that kind of thing can be simultaneously explored. I mean that with the development of the downscale information. So that's all from.
Okay, thank you. Lots to unpack there, but I think one of your key message that the lack of data shouldn't be an excuse for not doing something about climate change adaptation at the local level.
That's right.
And there are ways to go about it. Thank you very much. Before I proceed to these general questions on the anonymous attendees, I think we have two live ladies who wants to take the floor, who have raised hand. Tiffany Punsalan, can I call on you to ask your question and to whom you may be directing it? Are you there? Hello? Tiffany Punsalan? What about Astrid Cinco? Astrid Cinco? Okay, I'll go back to the Q&A chat board, but if someone from the Secretariat could help prompt them to be ready to ask their questions. Okay, Dr. Mizuno, another question, I think a general question for you, is AP-PLAT open to collaboration with other groups and organizations in the region, and what are the best options for such collaboration? I think you've provided some answers on this, but
okay, I just want to say something. As I introduced that we try to enhance the collaboration three channels. One is the development of science data, second development of the adaptation tools, and the capacity building. But in order to make them effective, we should first take stock on who are doing what. I mean that we don't know exactly who is doing what. Then I mean that ideally we should start doing a joint effort for the mapping exercise, exactly doing what and what is a missing element, where is a potential area of cooperation, so that we by doing this kind of a joint exercise for mapping, we can identify the good area of collaboration. I think that should be the first step for the effective collaboration, rather than ad hoc based to promote the joint efforts.
okay, would Laura and Essam have something to add to that as well? On collaborating with other organizations and groups in the region? Best options?
Sorry, Laura, please go ahead first.
Oh, I'm just saying that it does not need to always be initially a formal one. Exploratory talks are always welcome, and it's always good, like you said, the designing of activities and opportunities should also already engage the locals. So we meaning the academe can act as a go-between, to link up those who have the data and who have the resources with the communities directly. Because like Dr. Esam said before, sometimes the funding, for example, does not always trickle all the way down to the communities immediately. So if you link specific communities that we've already been working with for decades to institutions like that of IGS, then I think that will have a higher potential of working.
Thank you, Laura. Essa?
Sure. If you don't mind, I'll be slightly provocative to have this opportunity. I think this is pretty much linked with the decolonizing science agenda, because I think the way we refer to our stakeholders, for instance, the end users or the poor communities, or saving lives, etc., etc. I think it's become very inherent in the scientific community. I'm also blaming myself here, and I think there is a realization that there is demand within and outside the research or scientific community for reform of the way we work and how we work with our partners in particular. There is rising disquiet, I must say, with fly-in, fly-out research by those partly unfamiliar with the local context, and increasing concern that research teams should reflect more the places and the local expertise be valued as much as global experience. I think when we talk about partnerships, I think we need to challenge our current modalities in our partnerships and the way we work. And I would just, I'm into calling a spade, which is sort of, we need to decolonize in terms of the way we form our partnerships, and we challenge that with this very neo-colonial view. And when we talk about partnerships, I think we need to talk about the right partnership that gives us that sort of geo-contextualized approach in the way we do our scientific research. And therefore, we don't have to talk about creating demand, because the creators of whatever tool or service or scientific evidence that we generate is being championed and generated by those people who we work with as well. So I think unless we challenge the way we form partnerships, it will be very challenging the way we move forward. Sorry, I just thought, I think it's an opportunity to become slightly provocative, and leave people with something to think about after this event.
Sure. Thanks for that, Esam. There's a general question on socioeconomic questions and funding. So it's a very general, so we take it as how it is. What needs to be borne in mind when assessing climate finance? How can your institution help? So let's put it in a context. For example, there's a small NGO who wants to work in a specific community, and it's not the fly in, fly out thing, but they're actually in the community and they want to help, but they don't have the resources. Are there means? Is there means for them to access it through your organizations?
In the case of the academe, I think that's the responsibility of having the democratizing data, having that readily available to everyone. That's very important, as well as making sure that the tools that can be used on the ground is appropriately addressing what the ground actually needs, what the stakeholders need. So if we have both of that, I think then the resident NGO or resident people's organization will be able to take that and then run with it. And then they can always consult the local experts. So if there's a NGA that's specific for the marine environment, for example, or an higher learning institute that's also focused in the marine environment, then they can consult them if they run into anything. But I think first and foremost, you need to make those tools and data available, readily available and free. It's open for them to be able to access.
Okay, and then Ms. Funasan, would you like to respond to that?
Okay. Regarding the climate finance, I just first want to say that basically climate actions are the biggest framework for climate action is the UNFCCC, which is designed to facilitate the actions through national governments. And the biggest climate finance is the GCF, and that is basically therefore designed to be utilized by national governments. In other words, the biggest, not all, but many of the climate finance are designed to be utilized by national governments. Therefore, it is essential to have a close communication or synergies between the local government and national government, so that the local interests or the priorities can be well reflected in the thinking of the national governments. They are design for their adaptation plan or a project design, so that their interests are well reflected the project proposal, which should be applied to the GCF or GEF or World Bank or anywhere, IDB or anywhere. Therefore, I mean that one of the critical piece for the success is a sort of a vertical integration between the local governments and the national governments. That's what I want to say.
Okay, I will ask the last question. I think there are 2 questions here, but then I will skip those. How do we as individuals help foster local climate resilience? I guess our audience is also asking individually, how can we help? Not just organizations but as citizens of this planet. Misuno-san? What can they do as individuals to help foster?
Okay, you ask me?
Yes,
okay.
I'm going to ask the 3 of you.
Okay. It's a very challenging question, but there are several approaches the individuals can do. First of all, that people first, as I said, I want to repeat that everybody have to have a correct understanding of the climate change and the situation of the community. It's a foundation of the action. Everything have to start correct understanding the reality. Therefore, there are many people are guided by very malintentional information and something. Therefore, it's very important to know exactly what is happening, including the serious implications of climate change. That first thing. And then second thing, of course, that every individual affiliated with something, or usually organizations or community network, anything. So you can have some voice to directly encourage the actions of the community or industry or schools or everywhere. Okay. So you can have a voice. Okay, maybe stop. Stop.
Thanks. Okay. Just conscious of the time, Misuno-san, and I think you had given us a lot of suggestions on how we can help as individuals. Laura, very briefly, and then Essa.
Basically, you can only manage what you're familiar with. So familiarize yourself with your environment. And if you're near a coastal area, drive to the coastal area, walk to the coastal area, and just walk the beach up and down, and from the sea to the higher land, and see what's there. And you'll be amazed of what you can just gather from doing that.
Thank you, Laura. Essa, any thought-provoking response to that?
No, not this one. But I mean, yes, I think I do tend to agree with Samuel and Laura here. Is that I think awareness raising is really key. But also, I want to highlight that at a very, very local level, if we look at the household expenditure to build their climate resilience and to adapt the impacts of climate change, and you add that up in some countries, it completely dwarfs what's promised through the International Mechanism on Climate Finance. And I think it's not that communities are not aware. It's not that communities are not already spending. Communities are already spending. I mean, you can see in their household expenditure, all the expenditure they have in terms of trying to insulate themselves from the ill effects of climate change. I think the recognition of that is really important, particularly as it significantly dwarfs this, the promise of climate finance that may or may not arrive at a local level. So it's all about in enhancing the capabilities of communities at the grassroots level to diversify their means of livelihood and create those kind of opportunities, so that they do what they are good at doing, which is making a calculated, taking the calculated risk and making the right expenditure to try to insulate themselves from the effect of climate change. So let's not be sort of overconsumed about sort of the high level stuff, but let's get down to the community and grassroots level. That would be my message here.
Yeah, very, very wise suggestions from the three of you. Now we are about to wrap up. Nancy here, our senior program manager of in Pepsi rather, had this difficult task, but I'm sure she'll be up to it in terms of summarizing what happened, the discussions this morning, and tying it up with the discussions this afternoon. She's also leading the development and the preparation of our 5-year strategy. So she's got it on hand. So Nance, over to you.
Thank you, AG. Let me share my screen. Okay, good afternoon, everyone. Thank you, AG. Please allow me to introduce the highlights of today's dialogue on ocean and climate. This slide actually summarizes the scope of today's dialogue, particularly showing how global policies and responses to ocean and climate are translated and mainstreamed into national and local adaptation policies and action plans, with capacity building and access to ocean and climate science, tools and methodologies and knowledge management as important components to support their implementation at national and local levels. So the keynote presentation this morning established that the ocean matters in climate change discourses because it plays a central role in regulating the Earth's climate. And the keynote presentation also established that the ocean, the coastlines and coastal communities are at risk. They are being disproportionately impacted by increasing carbon dioxide and other greenhouse gas emissions, mainly from human activities. And majority of the presentations actually provided information on the consequences, which included increased ocean deoxygenation, acidification, warming, and sea level rise. We have also learned from the presentations that oceans and coasts provide critical ecosystem services, such as carbon storage, oxygen generation, food and income generation. And Dr. David highlighted that coastal ecosystems like mangroves and seagrasses play a vital role in carbon storage and sequestration. And they also provide ecosystem services as flood and for flooding and storm protection. And so the degradation of the coastal and marine ecosystems threaten the physical, economic, and food security of the coastal communities who are very vulnerable to the impacts of climate change. So as a global policy response to climate change, the UNFCCC was signed in 1992, and to boost its effectiveness, the Paris Agreement was adopted in December 2015, and where all the parties agreed to cut greenhouse gases emissions and to be implemented through their national determined contributions and national action plans. And in the keynote presentation also highlighted the Glasgow Climate Pact, where it is the outcome document from the COP26, which finally included ocean-based actions across all areas of work under the UNFCCC. And the pact specifically made direct reference to the need to maintain and sustain the integrity of coastal and ocean ecosystems. And so the Paris Agreement and Glasgow Climate Pact provide the necessary policy framework for the development of the NDCs and NAPs, which the 6 countries presented this morning. Although the pact did not define what ocean-based action means, nor does it provide specific guidance on key issues or priorities or highlight what those issues are at present. There are, however, tools, methodologies, and guidelines for advancing ocean action under the UNFCCC that are already available. And these were also presented or shared by our colleagues from the World Fish, UPMSI, IGES, and CCRS this morning, focusing on ocean and climate science research, capacity development, knowledge management, which could directly support the implementation of the NDCs and NAPs, as well as local implementation of mitigation and adaptation options. So there are global agreements and targets that also inform and guide the development and implementation of the NDCs and NAPs, and these include the Sustainable Development Goals, the UN Decade of Action for Ecosystem Restoration, the Post-2020 Global Biodiversity Framework, the UN Decade of Ocean Science. And as repeatedly mentioned this morning and this afternoon, so PEMC is in the process of formulating the next implementation plan for this regional strategy called the Sustainable Development Strategy for the Seas of East Asia. And the results of this dialogue will be incorporated in the formulation of the plan for the next 5 years. So these are the ocean-based solutions that were shared by the 5 countries. I will not cover the details, but in summary, the 6 countries have set emission reduction targets for 2030 and 2050 through their NDCs and NAPs, and they have also established the necessary interagency, multi-sectoral mechanisms to coordinate and accelerate low carbon actions and ensure green economic recovery and blue economy development. The 6 countries have also enhanced or in the process of updating their 2015 NDCs and NAPs in alignment with current climate science and new adaptation-based knowledge and good practices. Furthermore, the countries understand the ocean climate biodiversity linkage or nexus, which calls for actions prioritizing the protection, conservation, and restoration of critical ocean and coastal ecosystems for blue carbon and blue economy development. And finally, the countries have also mainstreamed or began mainstreaming as recommended by the Glasgow Climate Pact, ocean-based adaptation solutions into their NDCs and NAPs, as well as financing and pursuing national and local level implementation. The presentations this morning covered several tools, methodologies, and innovations, as well as data and information management, good practices, and knowledge sharing platforms to mitigate risk and enhance coastal resilience. So the next 3 slides summarizes the proposed collaborative actions that the region or PEMC as a partnership can consider in the formulation of the 5-year implementation plan. And so the anchor is the Glasgow Climate Pact because it includes actions to accelerate ocean-based solutions, and the following were identified: to conduct collaborative ocean climate scientific researches and studies focusing on the coastal areas, facilitating data access and information sharing to support local policy and planning processes, translating scientific data and information into stakeholder-ready format, facilitating the application of tools and methodologies to identify appropriate ocean-based solutions and mitigation and adaptation options, design tools that are fit for purpose, assessing in particular the demands and demonstrating the value of the tools to be applied from the perspective of the local people, promoting science communication to enhance awareness and understanding of local communities on climate risk, as well as the proposed adaptation and mitigation options or actions, engaging the drivers of climate change, including the big companies, in identifying and implementing ocean-based solutions. This was recommended by our colleagues from World Fish, with the inclusion of aquatic food systems in the NDCs, promoting incentive mechanisms for low carbon innovations and practices. Dr. David also suggested implementation of pilot engagement on adaptation mitigation partnership for carbon offset from our colleague from IGES to scale up local experiences in co-production of local climate adaptation pathways. This one was suggested by Dr. Lavinia, facilitating the development of programs on or approaches for climate financing, focusing on particular on the third pillar. The two pillars include mitigation and adaptation, and according to him, the third pillar focuses on loss and damage in support of the current climate negotiations. And as highlighted or repeatedly mentioned, PEMC will integrate the results and recommendations from the dialogue in the formulation of the 5-year implementation plan. And finally, PEMC was also recognized as a platform and as a platform or a mechanism to facilitate the implementation or application of the proposed collaborative actions by leveraging or capitalizing on the partnerships that have already been created in the region in support of the SDS-SCA implementation at the regional level to address transboundary and cross-country considerations as well as national and sub-national levels involving the country and non-country partners. Our existing networks of local governments, there are 52 of them in 10 countries across the East Asian region. Our learning centers, 18 universities and academic institutions in, I think, in also 10 countries in the region. Our 3 regional centers of excellence, which include UPMSI and IGES, and our other partners and collaborators. I think that would be all from me. Thank you, AG.
Thank you very much, Nancy, for that excellent summary. Nobody can do it except Nancy. So we're so lucky in PEMC to have her. So like we said, what are the next steps? So we'll be sending you copies of the proceedings and the presentations. Also, if the speakers, want to share this document, but I hope they will be able to. And some of the next steps also is that this event will help to inform policy activities and an article that will be developed in time for the International Conference towards Net Zero Emissions Policy and Practice that will take place in Hanoi on October 5, 2002. And then we are planning to echo the same dialogue, but this time strengthening coastal resilience towards local sustainable, towards building local sustainable blue economies with LGUs this time. So this will be with our PEMC network of local governments and other LGUs in Tangerang, Indonesia, sometime in November. Our chair this morning also has mentioned the possibility of organizing a side event during the COP27 from 6 to 8 November 2022 and present the results of these dialogues as input in the Ocean and Climate Annual Dialogue, which, as Nancy has mentioned, it's still a shell. There is no identification or prioritization of ocean-based climate adaptation solutions in that in the framework. So I think we would be one of the first to actually make some recommendations of how in the region we view this priority actions in regards to the links between ocean and climate. So there's lots of plans which we would like to keep you updated through our monthly bulletin or our email mailing list and in our social media. So finally, I would like to thank our excellent resource speakers. Thank you so much for spending your valuable time with us on this auspicious day, World Ocean Day. Celebrate with us. And also our speakers from the country partners, our moderator this morning, Dean Tony Lavinia, to showcase how our region is working together to address issues in the nexus of ocean and climate and implement solutions as well, and how we're continuing to do so. The PRF staff has tirelessly worked in organizing this webinar. And to all of you, to all the participants, thank you for coming and joining us in this webinar. Over to you, Days.
Thank you, AG. And that's it, ladies and gentlemen. That concludes our Ocean Roundtable Dialogue this year. Thank you again to all our speakers, our moderators, our participants for taking the time to join us in today's event. If you have not yet done so, kindly fill up the attendance sheet provided in the chat box and do follow us on our social media accounts for similar events and updates on PEMCI's work in the seas of East Asia. Thank you, everyone. Till next time, and happy World Ocean Day. Thank you.
Thank you. Thanks, Esam. Thank you, Laura.
Bye, everyone.
Sunusan.
Happy World Ocean.
Happy World Ocean.
Thank you.
Buslao.
Bye-bye.
Yeah. Happy 50th year also, the global environmental movement.
The ocean covers almost 3/4 of the planet. It's difficult to overstate the importance of the ocean for our life on this planet. Every second breath we take comes from the ocean. It's the source of much of our food and of our water. We travel and trade upon it, brings us joy and economic benefits in the shape of the world's tourism industry. It is clear that appropriate management of the ocean resources will be the key to reducing poverty and to achieving the Sustainable Development Goals.